All right. So thanks everyone for being here. This is day 2 of the themes 3 and 4 workshop for STEG. We have another great set of papers today. And the first couple papers are going to be on technology adoption in agriculture. Diego is going to moderate this for us. Just to remind you of the ground rules, the talks are 25 minutes. You can put questions in the chat. The moderator will have the discretion to decide what's a clarifying question and what can be saved for afterwards. And then we'll have 15 minutes of open discussion after each talk. So without further ado, Diego, I'll turn it over to you and we can get started. Thanks.
All right, thanks so much, Kevin. So we have a couple of interesting papers on technology adoption in agriculture. The first speaker is Shuhei Kitamura, and he will talk about tillers of prosperity, land ownership, reallocation, and structural transformation. So Shuhei, if you can share your slides and take the floor.
Yeah, thanks. Can you see?
Yes.
Okay, great. So yeah, good evening from Japan. Actually, it's around 10 o'clock in Japan here, but anyways, thanks for having me here, Vasily. Thanks everyone, Diego, for moderating the session. Okay. When we think of structural transformation, we might think of changes in the employment between sectors. For example, these figures show data from Japan between 1885 and 1965. The left figure shows that the employment in agriculture was nearly constant or slightly decreasing in the pre-war period, but suddenly decreased more after World War II. By contrast, the middle one shows that these people were absorbed by the non-agricultural sector. The period of notable changes coincides with a period of rapid growth in Japan. So between 1955 and 1973, the economy grew at the annual rate of about 9%, and the share of agriculture employment decreased from 40% to 15%. So unlike changes in employment, the changes in capital during the structural transformation are probably less well known. The left figure shows that the capital in agriculture was nearly constant or slightly decreasing in the pre-war period, but then suddenly increased after World War II. And the capital in non-agriculture was constantly increasing in the pre-war period, but increased more after World War II. And the share of agricultural capital decreased during this period. So in summary, these figures indicate that the labor was relatively abundant and the capital was scarce in agriculture in the pre-war period. But during the period of rapid growth, there was an reallocation of these factors, with more labor going to the non-agricultural sector and more capital going to the agricultural sector. So this research asked the question, what agrarian conditions to enable capital labor substitution in agriculture and the factor reallocation during the structural transformation? And as a motivating fact, developing countries today still have a high share of employment in agriculture. So answering this question might help us understand the underlying mechanism of structural transformation and the long-run economic development. So in this paper, as an agrarian condition, I focus on land ownership. The previous literature argues that secure property rights are an important precondition for economic development. However, the research on the ownership, in contrast to the security of property rights, has received much less attention. And studies examining the relationship between property rights and the structural transformation are also limited. So this research aims to fill the gaps. And to study the role of land ownership, I use a natural experiment in Japan, namely a massive land reform, which was enforced by the Allies between 1947 and 1950. The reform redistributed the ownership of 2 million hectares of farmlands from landlords to tenant farmers. Therefore, many tenant farmers became the owners of farmlands during this reform. This is an ideal setting to study the effect of land ownership. So to proceed the study, I constructed a unique panel dataset of municipalities using various paper-based sources. Then, using the difference in differences strategies, I examined the effect of land ownership on the adoption of agricultural machines, or more precisely power tillers, and the effect on local demographics, or the share of young people in the population. I also look at the effect on other outcomes, such as agricultural income, migration, and human capital accumulation. Main findings are the following. When new low-cost agricultural machines became available, land ownership increased adoption of the agricultural machines and decreased the share of young people in the population, and increased out migration of those people. And the main migrants were the second and the younger sons and the daughters, reflecting the sort of primogeniture culture in Japan. But the eldest sons also migrated if they were young. And the effects tends to be larger for larger farmers. And I also find that the higher the proportion of farmers who belong to a member of the agricultural cooperatives, which were the main suppliers of loans for the farmers at that time, the greater the effect. This is possibly because farmers get more access to the credit by using their farmland as collateral. Finally, I also find that land ownership increased agricultural income. Then, to evaluate the overall effect of this factor reallocation, I simulate a two-sector neoclassical growth model. And as a counterfactual scenario, I ask what would have happened if pre-war wages had remained unchanged after World War II. And I find that relaxing the wages in production increased the real GNP per worker per annum by 16% on average in the post-war period. And if the capital wage in agricultural production is only considered, it is 1%, or an increase by 327 billion yen if only the year 1965 is considered. And this amount is roughly the same as the government expenditure on land reform. So this study is related to a wide range of literature, in particular structural transformation, agricultural development, and land institutions and development. Although I do not go into details, the main contribution of this study is that it examines the role of agrarian institution, in particular land ownership, on factor reallocation and the structural transformation.
So Shuhei, can you maybe very briefly describe, because some people are wondering with the capital series, is that how do you separate the fact that capital was destroyed by the war and part of the capital increase maybe just the neoclassical accumulation process? How do you deal with that both in the empirical and the model?
So for the capital, so in the macro simulations, I use basically the data from the sort of kind of the censuses, but the sort of the war period is actually data sort of missing. So basically the data points start from 1947, which is a few years after the World War II. And sort of at least at the current version of the simulation, I basically use that data itself. But yeah, so that's my answer. So yeah, you use the data itself. Did I answer your question?
Yeah. Okay. We'll see the analysis with the model.
Okay. Yeah. Thanks. Okay. So just a brief overview of the research. In the next few slides, I will explain the background data and the empirical strategy. As mentioned earlier, land reform took place between 1947 and 1950. And during the land reform, property rights of about 2 million hectares of farmlands were transferred from landlords to tenant farmers. It was based on the compulsory purchase on behalf of the prefectural governors. The prices were very low, and there was no change in farmland size. And landlords could keep some of the farmlands, and there was an upper limit on that. I will use this feature as an alternative estimation strategy later. And the map shows the distribution of post-reform land ownership in 1950. The blue color means that the share of owner farmers are higher, while the red to yellow color means that the share of owner farmers are lower after the land reform. And after the land reform in the 1950s, in the late 1950s, US-made low-cost power tillers were introduced. And this caused a technological innovation race among Japanese producers. And in 1959, the agricultural machinery industry experienced a major shock. Namely, Honda's F-150 was born. So this was an epoch-making machine that used a new technology, and that was half the price of the previous machines. And the power tillers were adopted by farmers very quickly. At the same time, the new agricultural machines replaced the manual labor in the countryside. Then around the same period, there was a mass migration of young people from the countryside to urban centers such as Tokyo and Osaka. And the picture shows the young people wearing school uniforms who arrived from the countryside, greeting their employers in Tokyo. So to examine the effect of land ownership, I constructed a unique panel data set of municipalities. The main period of study is from 1950 to 1965. The unit of observation is the municipality in 1965, which is the most aggregated unit in the study period. And data sources are the following, and most of them are paper-based, so I digitized them by myself. And in order to match municipalities in earlier years with those in 1965, I created the municipality boundary shape files by myself and then used the GIS software to match municipalities across years. And the regression equation is the following. Owner share is a share of owner farmers when the land reform was complete. Post is a Toma variable for the availability of low-cost machines, which takes the value 1 if year is 1960 or 1965, and 0 otherwise. And I include the pre-treatment controls interactive with year dummies and the municipality and the year fixed effects. I also include the prefecture by year fixed effects in some specifications. And the main outcome variables are the power tillers per farm household and the share of the population aged 15 to 19 years old. So the identification assumption is the following. The municipalities with the high owner share would have behaved similarly as those with low owner share if the low-cost agricultural machines had not become available. And I visualize the parallel trends and conduct various robustness checks to check the assumption. And yeah, let's move on to the results. So as shown in the top figure, land ownership increased the adoption of power tillers. And as shown in the bottom figure, the land ownership decreased the share of young people in the population after the introduction of new agricultural machines. And there seems to be no systematic difference in trends in the pre-treatment period. And the effects became larger in 1965 as compared to 1960. And to interpret the magnitude, if I take the average effects of 1960 and the 1965, one standard deviation increased the share of owner farmers, increased the adoption of power tillers by about 1 standard deviation, or about 800% of the control mean. Well, because that pre-treatment period basically number of power tillers is quite low. And also it decreased the share of young people in the population by 0.65 standard deviations, or about 7% of the control group. So the effect seems to be large. And the same results can be shown in using the different figures. And these figures show partial correlation between the owner share and the power tiers per farm household. In 1950, or before the introduction of new machines, the slope was almost flat, but the positive slope appeared in 1960 and then 1965, meaning that the municipalities with high owner share are more likely to adopt the new machines. And similarly for the share of young people, although the slope was flat in 1950, it became negative in 1960 and then 1965, meaning that the municipalities with a high owner share are more likely to have fewer younger people in the population. And I conduct various robustness checks, such as adding more controls, dropping observations, and checking the existence of confounders and so on. And in particular, in the strategy highlighted with the green color in the screen, I compare adjacent municipalities along either side of the prefecture boundary. So as mentioned earlier, there was a maximum limit of farmlands that the landlord can maintain after land reform. And this upper limit was first determined at the prefecture level, and then it was determined at the municipality level. But importantly, it was constrained by the prefecture level values. So therefore, the adjacent municipalities along either side of the prefecture boundary might have received a different shock, just because they belong to the different prefectures. And I find a similar result with the alternative estimation strategy.
So Shuhei, just clarifying questions.
Yeah.
So what's the main driver of the ownership share? I mean, what feature of that reform led to that variation?
So basically, yeah, so it's not 100% so compulsory purchase of every, the land from the landlords to the tenant farmers. But there's some sort of criterion that sets some sort of upper limit, which says that the supposed upper limit says like, say, 0.6 hectares in a certain municipality, and the landlord in that municipality had 1 hectare of, the farmlands, then the landlords have to sell the 0.4 hectares of farmlands at least. That's a sort of the sort of variation where it comes from. Yeah, so that's why, and this sort of upper limits was sort of set by the prefecture level, and yeah, and then like this municipality level upper limit are also set, but average of those municipalities, as the average of upper limits of those municipalities has to be the same as the upper limit of the prefecture level. So that's why, in a sense, that so there are two municipalities in sort of either side of the prefecture boundaries and in the different prefectures, and they might be quite similar, but they might have got the different shocks because they are located in the different prefectures. So initially, maybe the different prefectures got the different upper limits. So that might kind of change the variation that these municipalities got in the end. Okay. And next, I also checked who actually migrated. The outcome variable is the number of migrated farm household members by age and type. And columns 1 to columns 8 are for sons, and column 9 is for daughters. And column 1 and 2 are for new graduates, meaning that those who graduate in either 1959 or 1960. And the columns 3 to 8 are for those graduated in earlier years. And unfortunately, similar information was not available for daughters. And I found that the second and younger sons and daughters are main migrants. And for example, looking at the columns 6 to 8 indicate that the second and younger sons migrated regardless of the age. And the column 9 indicate that the daughters are also migrated. And these findings may reflect the primogeniture culture in Japan, namely the eldest sons usually inherit the family lineage. But interestingly, I also find that the eldest sons also migrated if they were young. This indicates that the structural transformation is probably intergenerational to some extent, in the sense that the children got the non-agricultural jobs first, and then the number of farm households gradually decreases. And I also examined the heterogeneous effects using farmland size. And to do so, the average farmland size is divided into 10 bins using percentiles, and the marginal effect is computed for each bin. And as shown in the figures, the effect of land ownership on both dependent variables tends to be larger for municipalities with a larger average farmland size. Also, the effects are more or less linear. And to understand the underlying mechanism behind these findings, I examined the relationship between the land ownership and the credit access. And according to the policies in 1950s and 1960s, the subsidized loans were provided through agricultural cooperatives to farmers who wish to improve farm operations. And so I split the sample into 4 groups based on the share of agricultural population who belong to the agricultural cooperatives. Then I conduct a triple DID, where I set the Q1 as a baseline. And I find that the effects for both dependent variables are larger, where the share of this agricultural cooperative membership is also higher. And this might indicate that the farmers might have used their farmlands as collateral to get loans, which is sort of known as the De Soto effect. And I also examined the effect of land ownership on agricultural income. Since the income data are not available for the post-treatment period, I ran cross-sectional regressions, and therefore we need to be a little cautious about the interpretation of the results. But the first 2 columns in the table show the effect for 1960 and 1965, respectively. In the last column, I take the difference between these 2 years. And overall, I find suggesting evidence that the land ownership increased agricultural income. Finally, so due to the time limitation, I only provide a brief sketch of what I do in the simulation part. So I use a 2-sector neoclassical model to evaluate the overall effect of factor reallocation. First, I compute wages in the pre-war period, separately for the consumption, production, and the mobility component using the method developed in the Cheremkin et al. 2016. And the expression above is the wages for capital, and the expression below is wages for labor. And I know it's hard to interpret the equations without knowing the model, but I assume the standard Stone-Geary utility function and the Cobb-Douglas production function. The subscript small a indicates the agricultural sector, while the small n indicates the non-agricultural sector. So the consumption component here is based on the consumer's the optimization program, while the production component is based on the producer's optimization program. And finally, the mobility component is about the capital and the labor clearing conditions, labor market clearing conditions. And each of the components will become 1 if there is no wedge. So for example, if the capital freely moves across sectors, then the mobility component in equation 2 will be 1, and so on. And I find that the consumption and the mobility components are negligible. For example, the mobility component for labor in equation 3 was nearly 1, meaning that it is not the labor market wages that lower the mobility of labor in the pre-war period in Japan. But by contrast, the production component is large. So the production side seems to be the crucial to understand the inefficiency in the pre-war period. In particular, I find that the labor wage in the non-agricultural sector and the capital wage in the agricultural sector was especially crucial factors. And these figures just show how much the model fits the data according to the various economic indicators. The dotted lines are the data, and the solid lines are the model's prediction. And we see that the model fits the data relatively well. In the paper, I show the other economic indicators as well. And then I ran the counterfactual simulation by fixing the production component for the post-war period until 1965, and compare it with the actual values. And I find that relaxing the wedges increased the real GNP per worker per annum by 16% on average between 1947 and 1965. And if the capital wedge in agricultural production is only considered, it is 1%, or about the 327 billion yen, if only the year 1965 is considered. And as mentioned earlier, this is roughly the same as the total government expenditure on land reform. So yeah, to sum up, the massive land reform after World War II created many owner farmers. And I find that the land ownership stimulated the capital labor substitution, and in agriculture, when low-cost agricultural machines were introduced. And accordingly, the more capital was started to use in agriculture, and younger cohorts migrated. And farmland sites and access to credit strengthens to the effect. And finally, counterfactual simulations show that the impact of the factor reallocations on the overall economy was not negligible. And so this study shows that not only labor, but also capital is an important factor for structural transformation. And the agrarian institution plays a vital role in this process, given the low-cost agricultural machines are available. Yeah, thank you. Thank you so much for attention. I look forward to hear your thoughts on my research.
Thanks, Shuhei. Very, very nice presentation and fascinating experience. So while people get ready for their questions, let me get your thoughts on a couple of items. I mean, one is, so you make this distinction between ownership and kind of land security, but it wasn't clear to me in the empirical part whether you could separate the two, right? And I think from the policy perspective, it matters. Sometimes it may be easier to provide certificates of some kind, and so, but in particular, I will be interested, for instance, whether land ownership really you focus on reallocation of labor, but I think it would have been good to know more about the reallocation of land and kind of farm operational scales, how these happen. And that's when ownership versus kind of tenure security will make a difference. And in particular, I think you mentioned some law in Japan. I think it's called the Agricultural Land Act. And I'm just wondering whether that actually made reallocation of land not as easy, in the sense that I guess land ownership was distributed, but that law may stiffen the ability of individuals to just sell their land and go and migrate. So that's one. More of what happens to the land reallocation in this context. The second is about the model. I mean, I guess you went through that fast, and I'm not sure I understood all the details, but to me, my reaction to that is that you focus on kind of sectoral misallocation to look at this. And I think your evidence is really about, and to me, the most important channel is the within sector misallocation, right? Okay. And it's clear. So if you have within sector misallocation, that does not necessarily will lead to sectoral misallocation. I mean, I think in your context, probably yes, because if people cannot sell their land and migrate, then that's also going to generate a sectoral wedge. But to the extent that you have free labor mobility, then that's going to try to it's going to try to make that small. That's why I think to the extent that your data allows, I know you have farm data, you have municipality, but I think it may be interesting to try to push this to dig deeper into the within sector misallocation, because that's going to show up in your exercise as kind of a productivity gap, a real productivity gap, not a wedge.
Just perfect. So when you say that within sectors, so like just focus on the agricultural sector and kind of
no, to the extent, to the extent that kind of the allocation of factors within the agricultural sector will lead to low productivity in agriculture.
That okay. This is based
and
on
that
the
may or may not
productivity.
lead to a sectoral wedge. So you still have two sectors, but it may be that a lot of the variation is really about how this shows up in productivity, not on down. That's what I mean.
Thank you. Should I answer your questions? Or
Yeah, if you can make a comment on those, especially the issue.
Okay. So just so regarding the first comment about this land reallocation. So as you were right that actually after land reform, this land act has kind of imposed just after the land reform, which made the Japanese, it's quite difficult for farmers to sort of sell or buy the land. Basically, it's fixed for like about I guess 10 years or something. So during this period, the period I've studied until 1965, actually the land was sort of fixed in a sense. And the reason of this law was that basically the Allied, so they feared that maybe landlords going to take the land again from the tenant farmers. So the government had to impose that kind of law to prevent that kind of sort of deconfiscation. So that's one reason. So at least what I do in the research is sort of looking at the effect on the land size, which is perhaps not necessarily about sort of productivity thing, but I couldn't find a sort of change in the land size, and perhaps that's not surprising because that the land was relatively fixed during this period. Yeah. And regarding the second thing about the within sector sort of reallocation. So maybe the sort of the one drawback of this sort of historical data is that I don't have a sort of detailed household level data. So I'm kind of depends on what kind of thing I can do with the municipality level data. But do you have any sort of like any like what I could do? Like I can measure somehow the agricultural, I don't know, productivity at the municipality level, and perhaps look at sort of how.
Yeah, I think one idea would be
changed.
try to capture the heterogeneity through municipalities as if that's the unit of production. But
okay.
Yeah, either that or look at the agricultural census and try to get at least the farm size distribution that way. Okay, no, I understand the restriction. Just that in general, we find that it's in terms of productivity, it's the within sector that kind of drives more of the aggregate outcomes. Just because if you think about the way the labor market and other markets will work, they will tend to to the extent that there is some mobility, then that wedge is going to be small. Okay, so I don't want to monopolize time. So I apologize if I didn't see the raising hands in order, but I have Paula, then Jonas, and Julieta. Please unmute yourself and then ask your question. Thank you.
Thanks, Diego. I have a question that is somewhat related to what Diego asked. In the sense that, it would be nice to have more detail on the land reform. One of the things I was wondering is, I guess your variable of interest is the share of people in a municipality that own the land where they work, I guess, no? And then I guess the others are going to be renters to big landowners.
Yeah, exactly. Tenant farmers versus owner farmers. Yes, that's a kind of dichotomy thing. Yeah.
Okay, great. And I guess something that is one of the main concerns against doing these land reforms is that it might lead to farm sizes that are too small, and then scale is important for technology adoption. And you seem to find something on that sense, in the sense that larger farmers are more likely, or larger farm size is positively related to adoption.
Yeah.
So I was wondering, to what extent you can use, this experiment to say a bit more about this, about how these these forces interact. No, it seems that it's important that the workers that are working the land also own it for some reason, for getting credit to buy the capital goods, but at the same time, it's important to have a minimum farm size. So it seems that you are getting evidence for both sides of the argument. You know what I mean?
Mm-hmm. So sorry, what's the sort of trade-off? Two things. So the land size
so
and
one side of the argument is saying, okay, you should give ownership to people who work the land, because that's going to give them incentives to exert effort. They're going to adopt their technologies, etc.
And the other one, you say size?
The other side of the argument says, yes, but if you give the land to the workers, then land size is going to be too small, and that might not be an optimal scale for technology adoption. And you find evidence also of the second argument. So I think that's kind of interesting that you're finding some evidence in support of these two views, right? So I'm wondering whether you can exploit this experiment somehow to say more about this trade-off.
I see. Yeah, but so there's just
kind of an open
question.
I'm not sure what you should be doing, but it seems like an interesting variation, you know, that you have.
Okay. Thanks. Yeah, I think so. On average, I think it's, you know, Japanese farmland size is pretty much small. Like if you see this kind of figure that, you know, you see the kind of these mountains. I mean, the histograms. You know, hike is around like you know, less than 1 hectares, like about like you know, 5 acres or odd, like you know, half the hectares. So on average, the Japanese farmland is pretty much small. And basically during this land reform period, only the sort of ownership has been changed from the landlords to the tenant farmers. So in the sense that the land size is at least during this reform, it's kind of the same, but only the ownership has changed from those who are owning lands to those who are actually cultivating them.
Okay, but here I understood that you said that there was a cap on maximum land size. So if you own the small plot, you still keep it, but if your plot is too large, then part of it is
it's not the kind of splitting the size, but it's more like like just having the, not like sort of in a sense that you know, the upper limit is not kind of exact that you have to split the, you know, size into 2 or something. You just pick the same land size, but just either you have it by yourself or give it to someone. So without sort of splitting it.
Yeah, my understanding is that maybe the ownership changed, but maybe the operational scales did not change that much, because in the end, the tenants were given the land, right? So this is what I understand. But you know, Paula's point is that basically, if you had, and I think this is one advantage of our reform on ownership, is that if you have land reallocation that allows for larger farm sizes, that could even incentivize technology adoption even more. It didn't happen because of the way the law was implemented. That's the way.
That I think I agree. So you see that the figure that basically, you know, the effect is larger for the larger ones, and it's the effect is relatively linear. And in this figure, I don't include the Hokkaido, because Hokkaido on average has a quite large, it's more like a few, like 100 hectares of farmlands, and in those areas the effect is also larger. But so I think that I think it's quite interesting to the kind of things like how this size and the ownership or the property rights kind of things kind of interact with each other, I guess. And which is more important, I guess, is a kind of politically policy, you know, interesting, I think, question, I guess. But yeah, I think investigating something more about that, I guess. Yeah. Thanks for that. Yeah, cool.
I think I'm next, but maybe Julieta wants to go first, because I already got to ask some questions through Diego. So
it's fine, Jonas, go and then I'll ask.
Okay, so the question I had is related to kind of this ownership share. So I think it could have been, it would have been a bit easier maybe to get some more information on this. So my understanding was that you have kind of free reform, you have kind of very unequal ownership shares, and then basically as part of what the reform is doing is just equalizing ownership shares across villages, right? Across the municipalities, right?
Yeah, I mean, yeah, right. I mean, well, I think it's
So
maybe
it's
better
most
to-
binding. The reform is most binding for ones where ownership shares are pre-reform very unequal, right?
Well, yeah, unequal or like half owner, half tenant. Sort of.
Yeah.
I can show you the figure
Okay.
now. Sorry.
But so just based on this, I
Yeah.
feel
So this
Yeah,
histogram shows the pre-reform and the post-reform distribution of owner share. So
Yeah.
pre one is the sort of like this white one, and the post is like this blue one.
Yeah.
So yeah, well, yeah. In a sense, I think it's more inequality to equality. I think, but
exactly.
yeah. But yeah. Mhm.
Right. So just just to think about kind of the different diff and like who's kind of most treated here, I guess it's kind of the municipalities that saw the biggest changes in ownership shares, right?
Mhm.
And so
Yeah.
so there, I mean, I have kind of too little information on exactly kind of what correlates with ownership shares before, but I think it would just be nice to see this. I mean, you're doing all these controls, but I think it would just be nice to see kind of a bit more at baseline what correlates with pre-reform ownership shares, right? Just to think of like what kind of issues could this have, and that's just a just a
But
an expositional point. But then on top of this, just like a technical point, I guess for me it feels like in this setup, these more newer different diff methods, that kind of fuzzy different diff, for example, they might be kind of more suitable to what you want to do, right? Because basically everyone is treated here, right? Some are more treated than others.
Mm-hmm. Yeah,
And
so they hear the
so I think
higher
that is a
ownership
classic
versus-
different diff. You want to have like a pure control group, but you don't really have this here, right? So
then not the 0-1 damage, just a continuous variable. Mhm.
So then, so I'm just thinking like this fuzzy different diff, for example, could be a good way to.
Okay.
I can send you this reference, but I think some of these estimators kind of more clearly take into account that everyone is treated and this treatment kind of changes.
Yeah. Thanks so much.
Sure.
A very, very interesting paper, Shuhei.
Thank you so much.
So I have one question on kind of more a wish list of more stuff that I would like to see, and one related to an interpretation of one of your results. So I think it would be really nice if you could tell us what was happening with the price of labor as all this process was happening, just because you would expect fine, there is a shock, which is the reform, but at the same time, labor is becoming abundant. There is a lot of, labor is becoming scarce. Prices are moving. And yes, there is the technological innovation that is suitable for small scale, but I want to know what the relative price of kind of a machine to labor was, right? If you think of, say, if you think of the paper by Manuel and Seshadri, kind of documenting adoption of capital in the US, you see that there kind of the key trade-off is what's the price of animal power versus machine power. If animal power wasn't a big deal here, it was mostly labor intensive. I want to also see those prices. I would like to see, and that's going to be, you didn't have time to talk about this, and I kind of skimmed through your paper. In the model, it's not very clear how you're using this wage data to discipline the model, if at all. But I think it will be important to understand what these relative prices look like. And, correct me if I'm not right. So that's point number one. Point number two, I think your results on kind of variation on how many of these farmers belong to a cooperative prior to the reform is interesting. You interpret this as kind of telling you something about whether they were able to access credit, because most of those loans were given through the cooperative. But what might be going on is that they're just better institutions for sharing equipment across these locations, right? It's not really whether they access the capital or not, it's whether they have a more efficient way to use that capital. So I don't know exactly how you would disentangle this effect if you don't have data on loans, for example, but I don't literally interpret your results on kind of the higher incidence of adoption in places where there were cooperatives as directly evidence of credit, absent any, there are many reasons why that might be correlated. And I think it will be interesting if you can provide any other evidence on top of your current interpretation to kind of support that.
Right. So regarding the second one, actually, I probably not in the current version, the previous version, I had a one like regression table about using some communal power tiers versus like individual power tiers. So here the communal power tiers, I think this similar to what you have described. So sort of people rent out, from the agricultural cooperatives, but I didn't sort of find significant results for this communal power tiers. So that might, might perhaps explain that maybe, at least not perhaps this, not channel, but But regarding this price, labor price and the price of capital, I understand. Yeah, that's true that I don't have that kind of things, but sort of, at least that what I know is that the price of machines was held because of the Honda's this 150, this which is a half price, and also I remember that in the macro data, because I don't have a disaggregated wage data, it's only the macro level data, at least that the sort of wage in agricultural sector kind of increased, which is perhaps not surprising because that the labor is going out and sort of wage increases. But I think I should think of how I can make a figure about sort of trackable sort of evolution of prices.
So Shuhei, we need to move on to the next paper, but very interesting talk. I mean, I think related to that, this question came up before, is that over time with the war and the decreasing capital, of course, then there's the increase in the return to capital, which will incentivize.
Yeah, that's a sort of model type.
I think that is something that it wasn't clear how you dealt with.
At least, so I have data on the bombings, like where the bombing happened. But these data is like how many sort of cities destroyed, those kind of things. But I don't know. That's because the current macro model is kind of aggregated, just one sort of no space in it. So in order to incorporate this kind of capital distraction across space, I need to sort of extend the model to increase the spatial element in it. But I will think about it. Yeah.
Okay. Yeah. Thanks so much. So we should move on to the next talk. So we have Nicholas Swanson. He's going to talk about appropriability of returns to training as a barrier to agricultural technology adoption.
Yeah, Tillmann, it's 7:45, so you may start, please.
Okay. Thank you, Victor, and thanks everyone for joining. It's a pleasure to present this paper, which is, as we just said, my job market paper, and it's actually the first time I'm presenting this externally, so your feedback is much appreciated. I'll talk about how rural marketplaces shape local development. As economists, we're of course used to thinking about markets, but often in a relatively abstract sense. As the Oxford Dictionary puts it, markets can mean the potential demand for a commodity or service within a demographic group or geographic area. The original meaning of the word market, however, is much more concrete and physical in describing a meeting for the purchase and sale of provisions, typically in public, at a fixed time and place. And so it's this notion of markets as a location of exchange that I'm going to look at today. These markets have been common throughout history, documented around the world in various historical settings, and remain important in rural areas of developing countries today. For example, in Ethiopia, where the picture on the right is from, the vast majority of vegetables that are grown for sale are actually sold at marketplaces. So for a development economist, that poses the obvious question of how these rural weekly markets shape local development at the marketplace and around them. To study this, we would want to answer two questions. The first is whether where marketplaces are and what's happening at them. And secondly, whether it's marketplaces driving development or marketplaces just being a consequence of development overall. For the first question, since these markets are typically in rural areas and almost by definition a way of informal exchange, they are typically not well represented in official data sources. As a matter of fact, often we don't even know where these marketplaces are, let alone what's happening at them. Also, we don't have time series of development at a level of marketplaces that would allow us to look at this question over the longer run. In this project, I'm aiming to make progress on this question by using historical sources and novel satellite-based methods to document patterns of marketplaces and development around them, in particular population density, looking at the case of Kenya over the last 50 years. Now, with this data, we would still wonder whether it's marketplaces driving development or the other way around. Empirically, that's a very difficult question to answer because marketplaces are part of complex and historically grown economic networks where it's hard to think of natural or actual experiments that would sort of randomly allocate where markets are and where they don't exist. We might want to turn to spatial models here, but typically the models of domestic trade that we have are really focused on explaining trade from where stuff is produced to where it's ultimately consumed. And they don't allow for this notion of places of trade where neither consumers live themselves nor producers actually produce, but where people come together to trade. And this notion of a trading place away from where people live and produce is really central to this concept of marketplaces that I'm going to study. So in this paper, I'm going to integrate marketplaces into a spatial model, conceptualizing them as import and export hubs to and from rural areas. And I will use this model to identify possible mechanisms behind the empirical results that I see, and to illustrate trade-offs that policymakers may face when linking rural and urban areas to various kinds of infrastructure. I won't go through the contributions in detail, but let me just say for the first point here, there has been a very active literature by geographers and anthropologists on rural marketplaces in low-income countries. But this literature was ultimately limited by data availability to document marketplaces over time or link them to development outcomes. So let me give you a bit of context surrounding marketplaces in general and Kenya, the context that I'm studying here. So we may wonder why marketplaces exist in the first place, or indeed still exist in developing countries. In rich countries, they have sort of only minor roles, maybe as niche markets, and have been replaced by supermarkets and other forms of shopping. In developing countries, they, however, still persist. Why is that the case? Well, one reason is that population is often living still relatively dispersed, leading to high search and transport costs between people that marketplaces can address. There's also relatively weak legal systems in many contexts, meaning that farmers would prefer to interact directly with whoever is buying their output, and vice versa, see what they are buying in terms of manufactures. And finally, especially when it comes to agriculture, the volumes that are traded are typically quite small, so meeting at marketplaces creates these opportunities for bulking. This feature of marketplaces as being places of trade is, I think, nicely illustrated in this map here, which shows a part of central Uganda around Kampala here in the middle, and traces the itinerary of a clothing trader who lives in Kampala and sources his goods there, but then travels around the countryside to these different marketplaces over the period of a couple of weeks. In Kenya, where I'm going to look at marketplaces, were initially located sort of by decree and by the colonial administration, and only later, as later research has put it, it was decided sort of by supply and demand where actually markets would persist and where they would disappear. In the time period that I'm looking at, after independence, rural population quadrupled and agricultural trading was liberalized such that private actors were allowed to ship across districts and the state reduced its influence via marketing boards. Until today, marketplaces remain relevant evidenced by that each county's development plan, so there are about 50 counties in Kenya, each of those counties mentions policies that are related to marketplaces, be it the establishment of a new one or the provision of infrastructure, such as lights to existing ones. I also find in companion research that activity within these markets was actually growing at substantial rates, at least until the pandemic. So let me tell you about the data that I'm collecting here. The goal is to document market existence and development at the level of markets over time. And I'm going to do this focusing on this part of Kenya illustrated in the map here, which is home to around 50 million people today. I will look at 2 points in time, shortly after independence in 1970 and 2020 or today. The main variables that I will construct are first a measure of local development, where I follow the literature in economic history and urban economics using population density, or in my case, more precisely, the density of houses as a proxy for local development. I will also construct in both years distances to the nearest marketplace and a measure of access to non-agricultural consumers by constructing a measure of access to larger cities. I will arrange this data at the level of relatively small grid cells covering this region. Let me tell you about the markets data to start with. This comes from a research program at Makarin University in Uganda in the 70s, where researchers went around Kenya and collected lists of official markets from local governments, and which was consequently used for geographical research in the area, and researchers generally found that these lists were quite accurate. In the map on the right, we see in blue pixels that are, or grid cells that are relatively close to existing markets in 1970. For today, mapping markets today, I use a methodology that I developed in a previous paper, which uses satellite imagery to find those markets. I won't go through that in detail, but just to give you an idea of the method, have a look at those two images from the Google Earth archive of a place in Kenya, one taken on a Friday on the left and one taken on the right on a Thursday. You can see these smaller bright structures on the left here in this village square, where on the right the square is just empty. So we could, in principle, and this is the way a market looks in this context, I should say, from above. We could, in principle, teach a machine or task a human with looking around Google Maps or Google Earth and find places that look like the one on the left, but that would risk that we lose out on a lot of places, on a lot of markets where the image is not taken on a market day. Instead, I'm going to use imagery that doesn't have this resolution that Google Earth provides, but is instead captured daily over the last 6 years. And I'm going to use this imagery to look for places that change the way they look at a regular frequency. For example, every Friday. The imagery that I use is from a provider called Planet, illustrated here, showing the same place again on a Friday and a Thursday, where the gray square outlines the area that we looked at before. And if you look closely, and there's again this brightish patch here where my cursor is now that's absent on the right. And so again, I'm going to look for places that change the way they look every Friday and that are especially particularly relatively bright on a high share of Fridays, and which distinguishes meetings such as markets from sort of idiosyncratic patterns like this cloud here, for example. This method correctly identifies 85% of marketplaces in the validation data set, which covers markets in Western Kenya. And so equipped with this method, I then check basically all possible locations that one may suspect to have a market in this region. I start from the locations that had markets in 1970, then extend to known markets from policy documents, and further go via sort of road intersections and other population centers that you see in these maps. One limitation of this approach is that it only can detect weekly markets and not sort of larger daily markets occurring in large cities. I here assume that sort of administrative centers, county capitals, for example, that don't have weekly markets, instead have a daily market and record it in the same way as the weekly markets in the data on the right. as we will see this, it's actually very common even for large, relatively large towns to still have weekly markets. One may worry that this data comes from two different sources. One check that I can do here is that the frequency at which markets are held over the different days of the week is very similar between 1970 and 2020, suggesting that these two different methods indeed capture markets that are sort of qualitatively very similar. Now, if we want to know how development occurred or whether these places developed around those markets, we want to look at a longer time frame, then there's not a lot of data we can use. For one common source, censuses, for example, is not particularly useful in this context because it only records population at a much larger level than individual markets, for example, at the level of a district. Instead, I collected and digitized topographical maps that were drawn for Kenya in the late 60s, where these maps were based on aerial photography that was at such a high resolution that it allowed the interpreters of these images to identify individual houses that are here indicated as black dots and squares in this map. I use machine learning to extract the location of individual houses shown for the same spot in blue on the right. Equipped with this historical data, I then complemented with modern data provided by a team at Facebook, again here shown for the same place, which basically trained a machine to look at every 30-meter pixel in Africa and ask the computer whether this pixel contained a house or not. So this gives me the blue squares in the image on the right. I aggregate this data at the level of the grid cell, constructing this measure of house density similar to population density. And then my main measure of development is going to be how much a given grid cell has changed its rank in the district level ranking of grid cells between 1970 and 2020. So in the context of overall rising population density, some places have grown more than others and would then move up this distribution, which would show as a positive value for my measure of local development. Finally, I construct a standard measure of urban access from the trade literature, which just uses for each grid cell the distance to larger cities weighted by their respective population. So equipped with this data, let me show you three facts that I uncover. The first is that despite a massive increase in rural population and this trade liberalization that I talked about, there's actually a lot fewer markets today than there used to be in the 70s. In fact, of the around 500 markets that existed in 1970, only about a third still operates today. A small fraction has turned daily, but the vast majority has disappeared. As you can see on the right, there's a relatively large number of markets that have emerged since 1970. Those are mostly in areas that were previously owned and farmed by Europeans in large-scale plantations, and only later liberalized and given to smallholder farmers. Overall, there's a 30% lower market density today than there used to be in the past. So while this may suggest that markets are sort of not particularly attractive locations for economic activity, a different picture emerges when we look at what's happening in terms of population around. Here on the right, I show a bin scatter of grid cells ranked by their distance to existing markets in 1970. And on the y-axis, we see changes in population density. And as you can see from the negative slope, places that were closer to markets saw relatively higher population growth than those further away. While this is just pure correlation, one may wonder whether this rather reflects location fundamentals and not the effects of markets. I address this by including fixed effects for 1970 population percentiles. So even within comparing places that look very similar in terms of population density within 1970, places that were closer to markets grew faster. Another concern may be that perhaps markets were located at places that looked like they would have good access at some point in the future, but it wasn't actually important for that place's population back then and only became important later on. Again, after including, after sort of restricting the estimation to within percentiles of urban access in 1970, this relationship still persists. This general trend is also true for places that had very low population density in 1970. Basically similar population density to any other rural grid cell, suggesting that markets may actually be sort of nuclei of population agglomeration here. The third fact is that as market locations overall saw higher population growth than non-market locations, there's a spatial pattern to this, because this was especially true for places that were relatively far away from towns, from larger cities. So on the left, on the right here, you see with the long dashed line, grid cells relatively close to market. In the short dashes, grid cells relatively far from market, ranked by whether they are near or far to large cities today. And you can see that this difference between those lines is actually not so large when for places close to large cities, but gets larger the further you get away. Again, this reinforces this idea that maybe markets are these nuclei of where agglomeration happens. And this happens in particular in places that are relatively far from large cities and sort of out of this urban shadow that has been found before in developed countries. Equipped with these three facts, let me now turn to the model that tries to get at what may be driving those results. I start from the canonical new economic geography model, which is nice for my purposes because it allows to track sort of where trade happens or from where to where trade goes. And one can model the emergence of new towns at particular places in space. The key forces of this model are increasing returns to scale and non-agricultural production and transport costs between locations. I'm going to add to this marketplaces as explicit locations of trade, independent of production happening there necessarily. I'm going to assume that there are increasing returns to scale in transportation to and from those marketplaces. And I'm going to assume that some goods, non-tradables, can only be consumed at these markets. Let me talk you through how these different assumptions change the predictions of the model or affect the predictions of the model. So the model is very simple. You have a central city with farmers at some distance away from it, and farmers conduct constant returns agriculture, whereas manufactures are produced in the central city. Stuff gets transported in space, food flows from rural areas to the central city, and manufactures are shipped from the central city to rural areas at some transport cost. Now, placing markets affects how these prices for food and manufactures differ across space. In particular, I assume that the cost of shipping to and from a market, the cost of shipping between the central city and the market depends on how much supply is traded at that market. If a lot of supply is traded at a market exceeding some threshold gamma, then it's cheaper to trade through that market. And as a farmer that lives relatively close to a market, I may prefer going to the market and selling my goods there, which are then shipped by a transportation sector to the central city. Similarly, for how I decide where I want to buy my manufactures. Farmers choose a market based on where their income gets them the highest utility, and that pins down the supply that's traded at each market over some interval between sort of a farmer that's just indifferent between going to the central city or the market and people to the right of a particular market. Now, with these increasing returns to scale in transport, it may be the case that an individual farmer may actually want to go to a larger, far-away market rather than a relatively small but closer market, because that far-away market may offer better prices. That's a force for market concentration, because these smaller markets may die out. In terms of the population concentration we saw in the data, you can see from these graphs easily that markets shift up the incomes that people get from agriculture and lowers the cost that people have to pay for their manufactures. So in that sense, living around markets is relatively attractive. Now, beyond sort of it's an effect on making agriculture more profitable, this model also allows me to look at how a marketplace may develop into a town itself. The basic logic here is that a firm that's initially located in the central city may decide to relocate to any other location, depending on whether it can break even there. In breaking even, it weighs off the revenues it can get, depending on distance to its final consumers and other competitors producing similar goods, and the costs, which is basically just the reservation wage it has to pay for farmers to induce them to become laborers. Insight here is that with this basic setup, marketplaces are actually local minima in terms of how attractive it is for firms to settle there. That's because at markets, imports are relatively cheap, so I have to compete with them, and I have to pay my laborers a lot because agriculture is attractive for them. To break this prediction, I add concentrated demand with the notion that some goods can only be consumed at marketplaces. With this assumption, the market potential curve shifts, as indicated in the bottom, to being a local maximum at those places. So here, markets with their periodic gatherings of people are actually attractive business locations, leading to sort of a change from, potentially leading to a change from this place just being one of trade to also being one where these non-tradables are produced. We can spin this model forward until at some point this curve here hits 1 at some population level, and a town actually emerges there. We also see that there's this downward slope in the vicinity of the city, which just says being close to the central city is relatively unattractive for firms because they have to compete with firms being established in the central city. The same holds true for markets, possibly explaining this urban shadow that I saw in the data.
You'd have 1 minute. I mean, take 2 if you need, but
okay.
Yeah.
Thanks. I'll be quick. So with this model, we can now think about how markets can change our understanding of how to create linkages between rural and urban areas. In general, market access in the sort of abstract sense that I introduced in the beginning is creating this access is a policy priority, especially through road construction, but there's so far limited evidence that these roads can induce local structural transformation. So something that pushes people or that changes income opportunities locally from agriculture towards other sectors. I'm going to use the model to compare 3 policies and how they affect this transition, potential transition at markets. Specifically, I'm going to compare placing more markets, building highways, so connecting marketplaces in the central city, and building rural roads, so connecting farmers to those marketplaces. The results are here, where the way to read those 3 graphs is on the x-axis, I changed the policy, basically the number of markets or the cost of shipping. And on the y-axis, you have the population level in the overall economy that is required to let a town emerge at a marketplace. And anything that's above 1 here means that with this policy, a town emerges later. And anything that's below 1 means that a town emerges earlier. It's important to note that all these 3 policies are welfare improving. It's cheaper to ship stuff, but they may accelerate or delay the emergence of a town at a market. As we can see, both placing more markets and building highways delays town emergence in this model. First, because markets are relatively small with many markets, and with highways making imports cheap. But rural roads actually lead to larger markets and hence them being more attractive locations for business. And this is a change from the original model, the canonical model, which basically says that lower transport costs work towards concentration of activity in the existing city. So let me conclude. Marketplaces can shape development at the place itself and around them through lower transport costs and as nuclei of aggregation, especially in remote regions. And satellite imagery, something I'm excited about, is that this imagery lets us study these marketplaces over time and track transformational processes at them. In this project, I'm looking at relatively long-run effects on population density around marketplaces. And in future work, I plan to use remotely sensed market activity at a much higher frequency to look at short-run adjustments between markets. So thanks, and I look forward to your questions.
Okay, great. So Kevin, should I go ahead with like a few minutes, like I make a comment, I ask 2 questions? Is that the plan here?
Yeah, it's sort of up to you if you wanna take the first 1 or 2
Okay.
and you can answer them. And then go through.
I'll take the first. I'm sure there are even more relevant comments in the crowd here. So of course, like amazing data work, and this idea that markets arise endogenously to import manufacturing goods from the city and export agriculture to the city because there are economies of scale in transportation in bulk, like that's entirely sensible. Perhaps one thing I'd like to ask you about agricultural productivity, like the idea that markets develop into town has a really distinguished history in urban economics, is the thesis of Jane Jacobs and the economy of city. And there's a conventional wisdom that cities arise from agricultural surplus when agriculture is productive enough, but she says it's the reverse. It's like the market town that arises first, and then innovation and access to tools make agriculture more productive. So this mechanism is like, it's not in your model, right? Agriculture doesn't become more productive, it's close to market. And it's also not in your empirical work where more productive agriculture could be both a reason for a market and for higher population. So can you talk about agricultural productivity in your setup?
Right. That's very interesting. I think it's also empirically true that, of course, small towns do have this function of providing inputs to surrounding areas. In the model, I think it would be an additional force for the market being an attractive location if it offered goods that would allow farmers to become more productive in agriculture, and in a sense accelerate any of the effects I see, or the model predicts. In the data, it could be interesting to look at this area that I described before, where sort of the agricultural system changed dramatically over the time period that I'm studying. So where in this part of the map where there used to be no markets up here, where agriculture changed from being entirely based around plantations to being sort of small scale farming. Perhaps there's a way to look at differences and effects of where markets popped up here, of how agriculture looks there today.
Okay, thank you. So I'll open up to other questions and then I'll come back if there's time with whatever else I have to say. So maybe Paula, then Costas.
Yeah, hi. So super interesting. I find this fascinating. So one question I had is, what's the original variation in markets that you are using? So are these markets founded in colonial times? Are they at geographical spots like rivers? This was not entirely clear to me. So that was my question, basically, to give a bit more kind of background on the initial location of these markets. I mean, I guess the worry is this, idea that there could be some pre-trends or other reasons for faster growth in these areas related to geography or the reasons for locating them in those places.
Right. So the literature that I found on this basically says that marketplaces are really something in this area that was introduced by the colonial administration, perhaps for reasons of creating markets or bringing people into the market. And the way that worked was that, at least formally, local committees of local leaders could apply to the colonial administration to basically grant them a market right. Whether that replaced smaller informal markets or really created something new, is hard to trace out today. I mean, I think in general, given how dense markets seem to be in the past, it seemed like something that just had a lot of coverage, right? So there were a lot of markets, and then there was a change in where markets were over time. I think it's not. I'm not claiming here that sort of this initial allocation of markets is random and sort of.
Could you kind of, I mean, a basic test is to correlate the location with some initial characteristics, right? To check to what extent is, you know, as good as randomly assigned or very correlated with certain characteristics. You know? You could use geographic characteristics, you know, like rivers, elevation, you know, different, or population, no? Like in areas that were initially more dense. And then you can always control for those to the extent that there's some correlation, you can always control for those interacted with time trends to make sure you separate the effects of those from the effects of markets.
Right. I can definitely try correlate, like see what predicts market existence in 1970. My sense is that sort of this example here of of this place where there is a crossroads, are a couple of houses and there is a market, but it's by no means a large place. That's fairly representative. So I mean, it just makes sense to place markets at accessible locations, and maybe those accessible locations already had some houses to begin with, or they followed the market. But I can work to describe that further. Thank you.
Kostas?
Yeah, very nice talk, Tillmann. It's a great paper. I have two questions. I want one in the line of what Paul asked, I guess. So there is like not about the initial location, but like how new marketplaces emerge. It may be correlated with how new urban markets emerge, right? Or, you know, there's always obviously causality issue here that it would be interesting to discuss. Maybe you discussed and I missed it, but that seems like first order. And the second is like the model. It's kind of a little bit of an old school geography model, and what's missing really is like the space, right? Like it seems like the market access type thing of one region would affect the other region. Maybe I'll take the opportunity to advertise the stuff we have with Treballen, where, you know, roads nearby and roads access would affect, you know, like one market versus the other depending on the distance. So it seems like a straightforward extension to incorporate this type of ideas.
Right, thank you. Maybe let me start with the second question. Of course, I looked at those models. The reason I stuck to this relatively simple version for now, at least, is that I lack the data to estimate this model. Or like I don't have a lot of data beyond what I showed you now. I don't have stuff on flows between markets, for example, that would allow me to do sort of more quantitative analysis here.
Yeah, you don't need flows. I mean, distances would be enough.
Distances is
to some extent, of course. Yeah, flows will make it better, obviously, but yeah.
Yeah, and I mean, now I showed you sort of the most basic version here with just one market. It is perfectly feasible to have multiple markets on this line. Have different markets have different connections to the central city. That's something I'm doing in the paper. So there I can make some distinctions, but it's totally on the to-do list for the future to think about how this can be incorporated in a more complex model. In terms of where new marketplaces emerge and how towns grow around them, or the other way around, maybe I can show you this quickly here. So this is conditioning on distance to markets in 1970, where we know many of those have disappeared over time. I do find in this table that when I split in the first column, when I split by whether a market existed in 1970 or has declined since then or persisted until today, that it's the effect mostly comes from markets that persisted. And the data look similar, the results look similar if I look at places where markets have emerged since then. Again, this is sort of the strange feature of the data, that it's this region where a lot of other things changed, not just markets disappearing or not. In general, I do see that where markets disappeared is often sort of relatively remote regions, and the market, so instead of 5 markets being spread over the countryside, we now have 1 market in an advantaged location where then a city grows, or where it had advantages before already.
Yeah, I'm just, in general, I'm not big fan of these identifications. I mean, causality identification where you say, okay, something happened like 3 years before, and then it affects what happened. My identifications that just happened before. It seems what you're saying, because obviously people have expectations, they have knowledge. So if you know that the city will grow, then you can put the marketplace
Right.
rather than do it. So I know this timing assumption of identification is not my favorite, but I mean, so
I think I'm trying. I'm like, comment is very well taken. I'm trying to be very careful with any statement of causality here. I'm interpreting the patterns that I see, and there may be other explanations, and there's definitely more work to be done to tease them out.
Yeah. Thank you.
Thanks.
There's 2 minutes here. Are there any other questions? So perhaps I would ask you quickly, Tillmann, if you want to take a minute to talk a bit more about like how markets arise in the process of economic development. Like, what are the comparative statics here? You've noticed like rich countries don't have like marketplaces. So what are the comparative statics here? Are there like threshold of population and transportation where markets like arise and then disappear as countries become more developed? I don't think you had time to talk about this, so maybe take a minute to...
I think, at least in the historical context here, there has been sort of this external impetus for markets to come about. So even though the area was relatively densely populated already colonization, there were no sort of regular markets other than maybe yearly fairs where salt traders came from distant regions. So the impetus for markets here really came from that the government tried to integrate the rural economy with larger cities. I think then it's also important to note that these markets are not so much for local exchange in a context where the goods that are produced are not super diversified, but rather for exporting agricultural goods to the larger cities. And I think their markets have sort of this intermediate role during the process of development, linking rural producers to urban consumers. But then as development proceeds, as we know in our countries, markets are not particularly common anymore as sort of trade becomes more formalized and other and just the scale of agriculture changes, and large farms can sell to supermarkets directly without having to go through this intermediation.
Okay, thanks, Tillmann. Catherine, are you ready?
Yeah. We just need to let me share screen. So.
Okay. Is there a norm of clapping?
No. I meant this. Yeah.
for Tillmann.
Okay, everyone can see the slides. Okay, great. So thank you all so much. I'm really happy to be here today. I am a job market candidate this year from UBC, and today I'm going to be presenting a very shortened version of my job market paper titled How Do Establishments Choose Their Location, Taxes, Monopsony, and Productivity. So let's just to get started, why might we care about how establishments choose their location? The reason we care is because we care about how economic activity is distributed across geographic space. This is something that governments spend a lot of money on. To just give you an example here, the German government post-reunification in about 2020 had spent 1.6 trillion euros on attempting to redevelop former Eastern Germany, and a lot of the programs haven't worked very well. Now, there might be different types of incentives that different types of establishments are facing when they're choosing where to go. Let's think about a tech startup. They probably might care about getting workers that have very specialized skills for them. They might care about knowledge spillovers, getting the newest innovations. Whereas something like an auto manufacturer might care about being able to hire relatively more interchangeable workers, minimize their labor bill. And just as an example here, we have this quote from an entrepreneur who said, because of the lower cost of living, we could hire equally qualified employees at lower salaries in former East Germany compared to Berlin. Okay. So let's just contextualize. So I'll give you some background on the literature here, is that the benchmark papers studying establishment location choice are typically assuming perfectly competitive labor markets. This is the case in most spatial equilibrium models as well, but there are two exceptions. There's a 2010 paper by Ellen Manning and a John Mark from last year where they incorporate imperfect competition. But these papers don't have information on taxes that firms might have to pay, which also might be a relevant input into the location decision, as we know from some of the public economics literature. And these papers also have homogeneous firms. And we have reduced form evidence that there are multiple types of spillovers, and also some reduced form evidence that there are heterogeneous benefits of the different types of spillovers by industry. So just as a note, I'm just going to be using this term spillovers a lot in this presentation. So for those of you who aren't familiar with this literature, it's just the benefits that establishments receive from being located near other establishments in geographic space. And if you're thinking about the Marshallian theories of agglomeration, there might be three reasons that establishments might want to do that. The first is because you want to minimize your transportation costs, be close to good suppliers and buyers. The second is for some sort of labor pooling benefits, for example, minimizing your hiring costs or being located close to specialized labor that you need to produce your output. And the third is knowledge spillovers, which is a little bit more vague, but it's basically just the idea that you're gaining knowledge from being close to other firms in some manner. Now, we also have evidence that place-based policies have heterogeneous effects in different places across space, and the reasons for this aren't very well understood. So what do I do in this paper? What I do in this paper is I examine how the location decision of establishments is impacted by taxes, spillover, and monopsony power, and how these decisions affect local wages, as well as the impact of place-based policy. So I have three contributions in this paper, main contributions. I develop a new modeling framework of establishment entry, which leads to an estimating equation, which is tractable and very, very easy to estimate with an IV strategy. The second is I provide estimates of the relative contribution of taxes, spillovers, and local wage levels to the location decision. Then what I do, once with these estimates in hand, I take them back to my model and I evaluate the impact of a theoretical government tax policy using model counterfactuals. Okay. So just to give you a quick overview of the model that I have here, I'm not going to have time to go through all the details, but I'll try to get you guys the relevant bits, is I have geography, which in my case is going to be commuting zones. I have agents, I have workers who are in a single commuting zone, they're not mobile, and I have establishments, which are also located in a commuting zone. Now, the way that establishments are going to be approaching their problem is by backwards induction, which is how I'm going to take you through the model. The first step is workers with heterogeneous valuations of different employers choose an establishment where they want to work, which leads to a very standard in the labor literature monopsonistic labor supply equation. Then, both new and incumbent establishments solve for their optimal within location wage. Now, in terms of establishments choosing a location, in my model, only new establishments are choosing their location to maximize their profit. And what you should think of the style here, it's going to be like an industrial organization style differentiated products model. What you have in the industrial organization literature is you have consumers choosing between products with different characteristics. For example, a car that has a large car versus a small car. In my case, it's going to be firms choosing between locations with different characteristics. And I'm only allowing new firms to make this location decision because in my data, what I see is after an establishment is somewhere in space, only about 1.6% of them ever change locations. So I'm just abstracting away from that in my analysis to basically say that these establishments, once they're in space, they're most likely not going to be moving. Okay. So now just to show you the within location establishment problem, I have a fairly simple profit equation. I have firms are maximizing with respect to the wage, their profits. Why? They pay taxes. They have some sort of location marginal product of labor, which varies both by commuting zone and industrial sector. So think of it as different locations are more productive for firms in different industrial sectors. Think back to the example I gave you earlier about the auto manufacturer and the tech startup. They might value different things about different locations. And then they have labor, and then they pay a wage bill. Now, the labor supply equation here is coming from the worker side of the model, which I'm not going to have time to go over in detail today. But the key bit of this that I want you to keep an eye on is that there's this mu, which is the elasticity of labor supply faced with the firm, which is essentially the level of monopsony power that establishments have within a location C, as well as the outside option, which is, think of it as a reference wage level for workers in location C. Okay, so then after that, new establishments are also choosing their location. It's a fairly standard logit choice model. But because I only have sector level heterogeneity in my explanatory variables, the individual firm choice probability approximates the share of new establishments within a particular industrial sector M, which are choosing a particular location C in year T. Okay. So now after, again, I do some algebraic manipulation, I take logs of the profit, substitute all of my functional forms, I end up with this structural equation. Now, when I'm taking this to the data, what I do is I have data on taxes, so I control for taxes directly. This second term, which is more or less a market, you should think of it as a market size term because the L is population here. So think of this is like, if you're locating in a big city, it's simply a larger market, you can attract more workers. That's what this term is capturing. And I pre-estimate this using matched employer-employee data. The third term is a term which is a function of three things. The first is location times sector productivity beta, which I'm not putting any functional form on here, but think of it as a function of agglomeration, spillovers, natural advantage, really, whatever you think might be in there. And then the second, this B, is the worker outside option, as I mentioned in the previous slide. The third is this mu, which is the degree of the monopsonous markdown. And I'm going to be capturing this in my empirical specification by controlling for a number of factors which would be correlated with this term, for example, spillovers. B, then I have a number of other controls, for example, the share of highly university educated workers in a commuting zone, as well as I have location fixed effects in here. Now this last term, which is the base location characteristics, because this is all comparative, my dependent variable is the share ratio, is all cleanly captured in a time fixed effect because it does not vary across location, it only varies across time. And just as a note, the way I'm running this separately for each industrial sector because the share assumption is only valid within a particular sector. So I run this separately for each industrial sector, which is how I get heterogeneous valuations of the different characteristics for different sectors. Because, for example, this coefficient beta 1 is going to be different for each industrial sector because of the way that I'm specifying the problem. Okay. So now what data am I going to use to analyze this question? I'm using data from Germany. My main data set is the establishment history panel from the IAB, which is the Federal Employment Agency there. I have a 50% sample of all establishments in Germany and East Germany from about 1993 forward. But once I merge all of my data sources, my panel is from 1999 to 2017. And I use this to construct my dependent variable, the shares, the outside option, as well as my additional regression controls. Now, as I alluded to in the previous slide, I also pre-estimate the market size variable and the elasticity of labor supply facing the firm. And I do this using the matched employer-employee data, also from the IAB in Germany. Now, the third piece of data is local corporate tax rates. So just to give you all a little bit of background on the institutions in Germany. Germany has local corporate tax rates, which are set by municipalities, and there's a lot of variation in them. I think about something like 10% of their municipalities are changing their local corporate tax rates every year. So there's a lot of changes. And also these local corporate taxes are quite substantial. They're on the order of about 13% on average. So these are actually quite large taxes, and there's a lot of local variation, which is one of the reasons for me to use the German data, because it's quite unusual to have that much variation in local corporate tax rates. Now, my final area of interest is going to be proxies for empirical spillovers. And for this, I'm following the empirical proxies for the 3 different Marshallian agglomeration forces developed by Ellison, Glaser, and Kerr in their 2010 AER paper. So again, let's just touch on this again, the classic Marshallian theories of agglomeration. There might be 3 reasons why establishments might want to locate near one another. The first is the efficient moving of goods. Again, just like physically transporting things is easier across shorter distances, it's cheaper. The second is labor pooling, access to specialized labor, hiring costs. The third is knowledge spillovers. Now, what Ellison, Glaser, and Kerr do in their paper is they develop empirical proxies for all 3 of these forces. And they find that spillovers predict industrial co-agglomeration patterns. And then there were several follow-up papers which provide evidence that the relative importance of different type of spillovers varies between industries. Different industries care about the different things. One might care about efficient moving of goods, another might care about knowledge spillovers. So the Ellison, Glaser, and Kerr proxy is at the industry pairwise level. So I need to agglomerate, I need to aggregate that up into a location-based measure. So what I do is I take, for example, here in this equation, this max of inputs of sector and outputs from sector are the pairwise industry level, and then I take a weighted average by industrial composition at the commuting zone level in order to create a commuting zone level measure of this. So let's just go through the details of this particular one. This is the goods agglomeration measure. So the inputs from sector M prime to sector M is the share of sector M's inputs, which are coming from sector M prime. And the share of output going from sector M to sector M prime is the share of your output which you sell to sector M prime. So then for an establishment in sector M and location C, their total goods agglomeration benefits is the weighted average of these input-output measures, where the N is the number of establishments in the sector and commuting zone cell. I construct my labor correlation measure very similarly, but the pairwise measure there is the vector correlation of occupational shares between two industrial sectors. Okay. Okay, so now with all of this in hand, I'm going to return to my empirical specification. So you might be concerned about correlations of the local corporate taxes and local economic conditions, which may bias my estimates. This is very thoroughly examined in a 2018 AER paper, looking at the effects of these local corporate tax rates in Germany on wages, and they find no correlations between the local economic conditions of these local tax rates. Now, the second thing you might be concerned about is there might be local productivity or demand shocks, which are going to affect could theoretically affect both the share ratio, my dependent variable, and the spillovers and outside option, because as I just showed you, I'm constructing the spillovers and the outside option as well, though I didn't have time to go over that in this presentation today because of the length, as weighted averages. And because the dependent variable is the share of new firms and the weights are constructed as the share of incumbents, a local productivity or demand shock might affect both of those things simultaneously. So the way I take care of this is a fairly standard shift share instrument, which I'm not going to go over the details, but I'm happy to discuss it in the discussion if anyone wants to see the exact way that I'm constructing this instrument. Okay. So now here are the results of my specifications, and What is going on here is this, let's just talk about this panel here, this tax panel. Each of these is a estimate of the beta for taxes, and each of these is an industrial sector. So for example, what I see here in the manufacturing sector is I see a point estimate of about 12 or 13, and then the confidence interval. So what I want you to take away here is not the estimates for any individual sector, but the heterogeneity that you're seeing between sectors. So for example, what we're seeing here with taxes is that conditional on being responsive to taxes, there doesn't seem to be, the confidence intervals are very overlapping, but I do see two sectors here, which are the trade and transportation sector and the education and health sector, which don't actually seem to be responsive to taxes in their location decision. The second panel on the right here shows the response to outside option, which is the reference wage level in the commuting zone. Now, out of my sectors, again, I have two sectors, the manufacturing and education and health sector, that don't seem to take into account reference wage levels when they're choosing where to locate. But I do see evidence of heterogeneous response, for example, between the mining, utilities, and construction sector here and the professional services sector. The professional service sector really seems to care more about the reference wage levels available to workers. Now, the bottom two panels here are my measures of spillovers. The first is my goods measure, which seems less relevant for the majority of sectors, with the exception of the other sector, which is mostly personal services, which prefers to be located away from goods buyers and sellovers. The way I interpret negative coefficients here is as congestion effects. So think of it that there might be congestion effects of being located too close to other establishments that are using the same inputs or selling or buying, like things like that. So that might be why you would see a negative coefficient there. And in the case of the labor correlation, I also see a great deal of heterogeneity between industrial sectors. And again, the coefficients are negative, which I think suggests for the establishments that have this statistically significant coefficient that it's evidence that there's actually congestion effects in the labor market of being located too close to too many other establishments within your sector. It may be the case that there's also benefits, but they're outweighed by the congestion effects for most of these. I don't really have a mechanism to distinguish between those two things right now, but any feedback on that point would be appreciated. So, okay. So now, once I have these estimates, what I'm able to do is I'm able to simulate the effects of tax incentives designed to attract economic activity to a particular region. And I do this beginning in the first year of my panel, and I continue to the last year of my panel. So what I'm simulating is I'm simulating the effect of a policy of setting the local corporate tax rates to 7%, which is the lowest legally permitted rate in each of my 141 commuting zones. And I'm doing this separately, so just think of it like one commuting zone is setting their taxes at a time rather than all of them doing it at the same time, which would be more of a competitive argument. So now there's two effects of this change in the tax policy. There's the immediate effects of the tax policy, which is the direct effect of the lower taxes, which is going to attract new establishments to the commuting zone. But then there's also secondary effects. These new establishments that would not have been there normally is going to mean that there's going to be there's going to be different spillovers available to the establishments that are there. There's also going to be different outside options available to workers that are in the commuting zone. The overall effect of the tax policy is a combination of both of these things. For example, it might be the case that spillovers are actually reinforcing and that they might attract more establishments than just the tax policy would if you just simulated the tax policy with no spillover effects for the whole period. Or it might be the case that it would actually decrease the number of establishments by making it less attractive because you're creating negative spillovers for some establishments. The model isn't prescriptive about what's going to happen. So this is the distribution of the percent difference in the number of establishments. Each of these dots here is a commuting zone. The blue line is for simulating keeping the policy in place for 9 years. The red is keeping it in place for the full 18 years. So what you're going to be seeing is that there's actually evidence that keeping the tax policy in place for too long is actually counterproductive, that there's some sort of optimal length. Now what you can see is that about half of commuting zones actually experience declines in the number of establishments, while half of the commuting zones experience increases in the number of establishments. And this is suggesting that the effects of a place-based policy they're quite different in different places, depending on the pre-existing initial conditions. Then I do the same exercise for wages. Now, the wage effects, they're largely positive, but again, I'm seeing a lot of dispersion where the positive effects are varying somewhere between about like very, very close to 0 and about 5% increase in wages as a result of policy. Okay. So what could be explaining this? Because if you're thinking about it from the perspective of a policymaker, you might like to be able to predict what would happen in your commuting zone if you undertook this policy. Market power is explaining this. Now, just as a reference point, the mu, when it's increasing, we're getting closer to perfect competition. So what you're seeing here on the x-axis is as you're moving to the right, markets are becoming more perfectly competitive. So what you can see is that the growth in the number of establishments is higher in less competitive commuting zones. What this suggests is that place-based policies are going to be more effective in terms of growing the number of establishments in less competitive areas. And this is actually how, for example, the EU targets most of their place-based policies. That would suggest that they're doing something that's productive in that sense. Now, in terms of wages, there is weak predictive power of monopsony power. I haven't found any one factor that predicts the changes in wages perfectly. I'm still looking to see if I can find something, but I haven't found something that predicts the wage changes the way that you see the predicted changes in the number of establishments. And basically, so just to quickly describe, because I have, I think, 2 minutes left, the mechanism that's taking place here is that once the new firms are, if I take the derivative of the percent change in establishments with respect to market power, it's the mechanism of what's happening is that as a result of the new establishments that are attracted to the commuting zone, the productivity is becoming closer to the outside option on average. Which means that when you go back to the profit equation, a higher level of monopsony power is actually implying a decreasing relationship between the number of establishments in terms of the growth and the profits. Okay, so then some additional counterfactuals, just as a quick, because I have an extra minute, is that, so I've incorporated also extensive margin effects into these. So that would, if I incorporate extensive margin effects, the estimated establishment growth is a lower bound. So in general, you might expect to see higher growth in establishments with more extensive margin effects, which shouldn't be a surprise. Then I've also compared these results to what would happen if markets were more perfectly competitive. So if you're assuming perfect competition, you would underestimate the potential positive impacts of a place-based policy on growth of establishments and a little bit on wages, though the wage effects are actually smaller than you might think, because what's happening in the more perfectly competitive labor markets is that the outside option is less relevant. And in a lot of cases, what's going on in these commuting zones is the new establishments are bidding up the outside option. So you might underestimate the positive effects of the place-based policy in that case. Okay, so just to conclude, industrial sectors demonstrate substantial heterogeneity in the valuation of different location characteristics. The response to tax incentives varies greatly between locations due to spillovers and specific local conditions. Now, if you take these together, the efficacy of place-based policy in achieving your goals is highly context dependent, and the long-term effects of the policies is largely driven by spillovers rather than the direct incentive effects of the tax policy. So thank you all so much. I really enjoyed the conference, and thank you to the organizers.
Okay, this is great. Yeah, so so it's a discrete choice model. Firms choose a location where to operate, and that choice depends on, in a kind of reduced form way, on spillovers, wages in that location, taxes, and market size. And you argue you need all that richness to really study place-based policies. You and I can talk at UBC, so let's try to get you as many questions from other people as possible, and I'll come in if need be. But Roman, please.
Hi, Catherine. Thank you very much for the presentation. So I have like 2 questions that are kind of related. So my first question is about like the literature has focused a lot on in heterogeneous effects, like what is going to happen with the more productive firms versus the low productive firms. For example, Cecile's paper is more about like more productive firms are going to sort into the locations with higher productivity, so they are going to sort into locations in which agglomeration externalities are larger. And the same way with Manning's paper, like higher productive firms are going to go into a location in which they are going to face more competition rather than low competition. But you don't have like any kind of heterogeneity in your results, like in the regressions that you're running.
So I didn't present it. I didn't present it today just because of time considerations. Now I can't measure productivity directly in my data. So what I do to try to get at the productivity margin is I split the sample by high versus low AKM effect firms. So like the higher AKM effect firms would be the more productive ones. And what I find is that the low AKM effect firms actually place a higher importance on worker outside option, as in they're more repelled by higher wage levels. The second thing I find is that the low AKM effect firms are the ones producing my negative coefficients on spillovers, which the suggestion of that would be that the congestion effects are actually really only affecting the low productivity firms, whereas the congestion effects are not affecting the high productivity firms. So this is consistent with Cecile's paper. I would say that I'm studying a different margin than her paper, but this effect where the high productivity firms are less likely to experience the congestion effects, I'd say is consistent with her findings. Yeah.
Okay, and I also have another questions about like thank you for that answer. So I also have another question about the labor market power story. So you're assuming like monopsonistic labor markets, but there are, like other kind of market structures that can be out there. Like people now are working more with monopsonies, instead of oligopsony, they are working more with oligopsonies instead of oligopoly. So I was wondering, like, you have like just like one labor supply elasticity in your regressions, but those labor supply elasticity can actually be a function of the market share, not only just a labor supply elasticity by location. So I was wondering, like, how do you think that this can affect your results? And the second thing is, like, I noticed that your labor supply elasticity estimates are like super low, like they are around 1.5, between 1.5 and 3, and this is like super low compared to what the literature has found. It's more about like 5 to 8. So I was wondering, why do you think that you are finding this so low labor supply elasticity?
So there's a couple of things there. So the first would be the question about Cournot competition. So Cournot competition, for anyone in the audience who doesn't know this labor literature, is basically the idea that the larger firms are able to mark down wages further than smaller firms. So there's a couple of reasons why I don't incorporate Cournot competition into my model. The first is that the majority of establishments in my sample are quite small, as in I think my average size is about 4 employees. So if you're thinking about which establishments are going to be the ones that are actually realistically going to be able to mark down wages in a Cournot style way, it would be establishments that are a very, very small share of my data. Now, the second is that I'm aggregating everything up to the sector level. So having it be, I would need to really do more of a firm level model to be able to incorporate Cournot style competition into my framework. And that would require a very different estimation strategy. So I think it would be a different paper. I don't think it would necessarily be an uninteresting thing to do. I just think it's outside the scope here. Okay. And then the follow-up was about sorry, I actually forgot what the last bit was.
The low estimates of the labor supply elasticity. They are very low.
So they're not super low. I'm using the method from the Vasily, Dubé, and Einaudi JHR 2022 paper, and they're not actually so different from the estimates that they get in that paper. So I think it's an artifact of the method that I'm using, but I need to think about that a little bit more. Thank you.
Okay, thank you.
Paula?
Yes, I know, super interesting paper. I had a question on the estimation strategy. So if I understood well, you are trying to separate the effect of local taxes, market size, spillovers. So, you mentioned that, there's some paper that says that local taxes are unrelated to local characteristics. So I guess that's fine. But something that appears difficult is to separate the effect of market size and spillovers, right? Because usually, one of the reasons why we think, there are, firms like to locate, in larger markets, there are demand and supply reasons. Demand is to be close to customers, and supply because we think there are these productivity spillovers across these firms. So this, I think it's very difficult to separate these demand and supply forces. And from what I understood from your approach, your way of doing it is to, measure market size as the size of the market, but that is going to have both demand and supply forces. And then you put spillovers, right? So it looks like you have a measure that you're counting the supply forces twice, right? Because you have the size of the market and then the spillovers. And this is related to the fact that you find, for example, for the industrial sector, negative effects of these, of the labor spillovers, of having people working, which I think is a bit surprising or contrary to expectations. So I was wondering whether there was a way in which you could try to improve on this measurement to separate these, being close to the market and then you want a large market from being close to people doing the same as you because you're going to benefit from knowledge spillovers. It's difficult, but maybe there's a way in which you can improve that.
So that's a really good question. Thinking about it, probably, so just to be clear, because the way that the spillovers are constructed are more about the mixture of establishments right now, rather than there's no agglomeration effect within the spillovers itself. It's a weighted average, right? So it's more about the mixture of firms that are present. As a quick reaction, I could probably do some sort of interaction between the market size effects and the spillover effects. But yeah, I would need to think about that question a little bit more. But thank you. That's a really good comment.
Are there any other questions from the audience? Maybe I would ask you, Catherine, to talk a little bit more about identification in the context of your paper. Like you have a location fixed effect, a time fixed effect, so that's good. So because there's no geography in your setup, right? And like if you look at maps in your paper, like the whole northwest of Germany has really high taxes, right? So that entire region must have special characteristics and really high taxes. And then you identify some changes that's plausible. But I mean, there's a lot of stories someone could come up with, like the forestry industries, like if that's where like the forests are in Germany, and that's also where taxes are high, then that's a confounding factor. So do you have strategies aside from fixed effects to handle like all of these identification issues?
With the taxes specifically, no, I'm really leaning on the fixed effects to absorb the natural advantage component. I was looking at one point into getting data on the geographic characteristics of Germany, but I wasn't able to get it, unfortunately. So yeah, I'm really, as far as the natural advantage, I'm really I'm thinking of that the location fixed effect as as something incorporating natural advantage. Yeah. As far as identifying from the differences, yeah, that's the case. It's really just the fixed effect is doing the heavy lifting there.
And there's a shift share instrument for the spillovers.
Yes. So what I'm doing is I'm basically instrumenting the number of establishments in an industrial sector at the time with the number in the pre-period, which for me is 1998. And then I'm using the leave out growth rate of similarly sized commuting zones between 1998 and time t to predict the number of establishments and using those as the weights when I'm doing the actual regressions. So that's the instrument. It's pretty similar to the shift share style instruments you see in like the immigration literature, for example.
And the instrument is not at the location level, it's at the sector location?
Yeah, sector location.
Okay, so that's like
But I
unusual.
there's no way. Yeah, I could do it at the location level as well as the sector times location level. So because I'm running the regression separately for each sector, right? So that's part of the reason for that. But
Okay. Anyone else?
Can I will also ask another question. So
Yes, please.
so like you have like many like variables that generate like our market distortion. You know, taxes are market distortions, spillovers is an externality, so it's also like a market failure. So I was wondering like if you have thought about efficiency in this context and how like firms reallocation can affect like the optimal allocation of inputs across locations and across places when you do your counterfactuals, or if something that you haven't thought about it, and maybe that's for another paper. But I was wondering if you have thought about like the relationship between. Yeah, I mean it's for another paper, but I wanted to know if you have thought about like what are like the implications for efficiency in this case that you have like this additional channel. How do firms reallocate across locations when you change taxes and everything?
Yeah, no, so the answer is that's not something that I've thought about, but that sounds really, really interesting. And I think it would be a follow-up paper for sure. Yeah, thank you.
Okay, cool. Thanks, Katrin. So I'm gonna hand it in to the organizers here. I think there's a break.
Yes, we're gonna have a break until about 20 minutes from now. And then we'll move on to the next section on networks. Thanks, everybody.
Thanks for being here.
Hi, Kevin. Yeah, great being
Yeah,
here.
thanks so much for being here. I'm really looking forward to this.
Well, thank you for putting this together. If you are to blame.
I am. Well, in part, among with others, to be sure. And hi, Vasco. Thanks so much for doing this. I don't think we've ever had a chance to meet in person.
No, I think it's the first time. Thanks for inviting me.
No, of course.
Hola, Julieta.
Hi, Vasco. Hi, Alexey. Nice to meet you.
Yeah, nice to meet you.
Thanks for coming, guys.
Hi, Alexey. Hi, Vasco.
Well,
So, Alexey, is your co-author in here somewhere? Will he be in the Zoom or sorry, in the chat or anything like that?
no, unfortunately, no.
Okay.
He's teaching, unfortunately.
Yeah, no worries. So just to give you some sense, I'm not sure how long anyone's been around the Zoom today, but 25 minutes, 15 minutes for discussion afterwards. Vasco can keep an eye on the chat and use his authority to decide what's a reasonable clarifying question to break in with and what can be held for the end. And other than that, I guess we're all Zoom experts at this point.
Sounds great.
Famous last words.
Yeah, true enough. Hopefully this will be the last one. Also famous last words, I guess, but.
All right, I think we got less than a minute to go for the time on the program. We're super happy to welcome 2 papers on production networks. This is the last session, so let's keep timings correct so that everyone can go and relax. Thanks for being here. The first paper is sadly topical, but it's an exciting paper. So I'll give the floor to Alexey. Alexey, 25 minutes. I will try not to interrupt unless there's some burning questions.
All right, thank you very much, Vasco. So it's a pleasure for me to be here. So thank you very much to the organizers for including the paper in the program. So this paper is called Production Networks in War with Evidence from Ukraine, and I'm My name is Alexey Makarin. I'm from MIT Sloan, and my co-author is Vasily Korovkin. He's from CERGE-EI. He's teaching at the moment, so he's not in Zoom. He's not present in Zoom, but he's with me with thoughts. So at the stage of the talk, I typically motivate why we should care about studying conflicts and why we should care. Oh, sorry about that. Why we should care about the 2014 Russia-Ukraine conflict in particular. Unfortunately, since about 6 months ago, this motivation became not needed anymore, unfortunately. So let me just state that Vasily and I have been absolutely devastated by the ongoing war, and we hope that this senseless aggression by the Russian government stops immediately. So we can only hope at this point that our results in this paper would be at least somewhat useful for practitioners and policymakers in thinking about the economic consequences of the current ongoing escalation. So with that, let me start talking about the conflicts and the economic consequences of conflicts more generally and the specifics of our paper. So when we think about the economic consequences of conflicts more generally, so one immediate set of consequences are the direct costs for those who are located in the violent areas. And there is, of course, the loss of human life. There is, besides that, there is damage to infrastructure and physical capital, and there are numerous other social and health effects that have been studied quite deeply. I mentioned a couple of papers here. But however, a set of costs that is typically left unaccounted for in the literature are the spillovers on people and firms who are not directly exposed to violence. And why we should care about the spillovers is first, at least as of 2016, around 2.6 billion of people lived in countries with ongoing conflicts, but at least 50 kilometers away from the violent events. And second, if the spillovers of conflict are non-zero, then the traditional estimates in the literature within country estimates that compare violent and non-violent areas and the differences of energy control framework, they may underestimate the total economic cost of conflict quite significantly. So, and in particular, there has been very little evidence so far of the spillovers of conflict on firms. And for instance, you may imagine that conflicts create severe negative demand shocks that may propagate and decrease demands for other inputs. Alternatively, you may think of supply chain disruptions that may be caused by violence and by the destruction of this infrastructure. And this type of spillovers, we would expect them to matter, especially in countries that are middle income countries and industrialized economies. This is unfortunately where conflicts are more and more frequent over the past several decades. So what we're going to do in this paper, so we're going to estimate the spillovers of one of the largest conflicts of the past decade, which is the 2014 Russia-Ukraine conflict. And we're going to study the spillovers of that conflict on the rest of Ukraine. So the setting is, we argue, close to ideal for studying spillovers of conflict. So first, why? Because there's no violence taking place in the rest of Ukraine. The violence was relatively localized. I'll show you the map where you will see that. Also, this was a very massive shock to the economy of Ukraine because Crimea and Donbass were together responsible for 17.5% of Ukraine's GDP before the war. And to study trade within Ukraine, we're going to analyze the universe of firm-to-firm railway shipments from 2014 through 2016, so before and after the start of the war. And this data allows to track the evolution of the production network and the intensity of the links before and after the large persistent shock, in this particular case, the war. And this makes this data pretty unique, not only in the conflict, especially in conflict literature, but hopefully in other, like in economics more generally. So we are not too worried. This is a subset of all transactions. I'm going to talk about it in just a second, because we're not too worried because railroads are actually the main way of transporting freight within Ukraine. So let me preview our findings. So first, we provide evidence for the propagation effects of the conflict shock, and by the propagation effect, we mean that war affects not only firms in close proximity, but also the trade of those firms with their buyers and suppliers, and the trade of those buyers and suppliers with their own buyers and suppliers, and so forth. So we document this in the differences framework in the spirit of the production network literature. So we find that indeed, if you take two firms, both of them are located outside of the conflict area, but one of them had traded with someone in the conflict area before the start of the conflict. Trade within that pair of firms between those two firms goes down as well. We call it the second degree effect of conflict, and we find that it's about it's negative, and it's about 1/4 of the first degree effect of conflict on trade. And importantly, a naive difference in difference specification that ignores the type of spillovers and only looks at the first degree effects of conflict on trade would underestimate the total impact of conflict by about 67%. So second, we argue that the conflict shock does not only propagate through the production network, but also in case it's very big, and in our particular cases, it was very big and massive, and it cut certain regions of the economy off from the rest of the country, it could also change the production network structure itself, and this could potentially affect the individual firm performance. And indeed, we do find that some evidence for that. So specifically, we find that firms in non-conflict areas that exogenously gained in terms of their network centrality as a result of this change, they experienced a boost in relative terms to their sales and profits. And finally, we use a production networks model to separate the contribution of two ways in which the network structure changes with the start of conflict. So the first way, we call it network destruction. By network destruction, we mean that conflict removes certain firms from the network for various reasons. The second mechanism, we call it network adjustment. It describes a process by which firms in non-conflict areas after the start of conflict are now, changing their suppliers, buyers, and forming connections. So we find that the network destruction in the set of contractual exercises, we find that the network destruction reduces the median firm revenue in non-conflict areas by about 47%, and the network adjustment compensates for about 80% of that decline. So in other words, network adjusts quickly, but does not bring the median firm revenue back to its pre-war levels. And hopefully I'll be able to tell you the details about of how exactly we do that in a second. Okay, so I guess I will skip the literature, but mostly we contribute to the literature on conflict and the economic impact of conflict, and specifically conflict firms, but also we hope that we make some progress in the production networks literature as well. Yeah, you'll be the judgment. All right, so the outline of the talk is pretty standard, so I'll talk about the background and the data right now, and then I'll present the results, and the results again would be split into three parts, as I just mentioned. So the first part is propagation, the second part is this network structure change effect that we document, and then the final part is going to be disentangling this just a network destruction versus network adjustment in this production network framework. So as you may know, in February 2014, Russia conducted a covert military intervention to annex Crimea, which is at the bottom of the map. And later it started promoting secessionist movements in the east of Ukraine, which is this Donetsk and Lugansk regions. So especially these gray areas, they were proclaimed independent, and they were called, they were so-called Donetsk and Lugansk People's Republics. So the annexation of Crimea went relatively peacefully in terms of the number of casualties, but the conflict in the east of Ukraine turned very violent. And as of February 23rd, 2022, it was responsible for more than 13,000 casualties and more than 2 million displaced individuals. So one key takeaway from this map as well is just that you can see that this violence in this context was relatively localized to this particular area in the east of the country, and most of the country, most of Ukraine, was not directly exposed to violence. So there was no violence popping up in other parts of the country that was really associated with this kind of guerrilla fighting. So very quickly, some background on the economy of these regions. So Donbass and Crimea were actually very important for Ukraine. So together, as I already mentioned, they were responsible for 17.5% of pre-war GDP of Ukraine. Donbass contained a lot of extractive industry, metallurgy, and was responsible for 26% of all Ukrainian exports, especially Donbass, especially Donetsk region is important here. And Crimea was less important in terms of manufacturing, but still produced a lot of agricultural products, and it had a lot, it is a very populous region that could be important for demand as well. And because of the conflict, the occupied areas were practically cut off from Ukraine's transportation system. And as you can see from these numbers, the manufacturing fell dramatically in both Donetsk and Lugansk oblasts. You can also observe it from the nightlight satellite data as well. There is kind of a paper not by us, but that does it as well. And what we specifically, what we're going to do in terms of data sets, we will rely on the universe of firm-to-firm railway shipments within Ukraine from 2014 from 2016. So this data includes the dates, weights, the product codes of each transaction. We merge this data with the accounting data for the universe of Ukrainian firms, and from there we get sales, profits, capital, and we can get some other information as well. So we want to preempt the potential questions about the alternative modes of transportation at this point by saying that 80% of all freight within Ukraine in ton kilometers has been transported using railways. Okay, so in the US, this number is about 33%, as far as I know. So you can see that in general, railway freight is very, very important for Ukraine. So we do not think that we are missing too much of the action. So in general, as you can see from these numbers here, Ukraine's railroad infrastructure is actually very good, not only compared to other countries, but potentially compared to other modes of transportation within the country itself. For instance, road transportation is quite poor at the time. So this is a quick illustration of our data. So the dark black lines represent the railway network of Ukraine, and the red dots here are the railway stations that we have in our data. So these red dots are not coming from kind of outside source, that they are actually in our data. So the fact that these dots cover the whole territory of Ukraine already give us a sanity check that indeed we have the universe of all transactions here. And second thing that I wanted to mention is that the fact very much consistent with the fact that Donbas heavily relies on upstream sectors that in turn rely on railroad network infrastructure. You can see a very dense cluster of railway stations in the Donbas region. So again, that sort of justifies our usage of railway data in this context. So let me get to the results. So first, we'd like to present you some evidence of the propagation effects of the conflict shock. So for that, we estimate the following specification. It is a difference in difference specification in which, again, which is in the spirit of the production network leadership. So on the left-hand side, we have trade firm I to firm J in the month T. On the right-hand side, we have the firm pair and direction fixed effect, the year-month fixed effect, and the two interaction terms. So the first interaction term is between the past contact indicator and an indicator for whether one of the two firms is directly located in the contact area, either Donbas or Crimean. So then the second interaction term is between the past contact indicator and an indicator for whether one of the two firms had traded with someone in the contact area before the start of contact. So the beta 1 coefficient gives us an idea about the first degree effect of contact on trade, and the beta 2 coefficient gives us an idea about the second degree effect of contact on trade, or the propagation effect, as we call it. So we're not including the third and the fourth degree propagation. Why? Because it's just the network saturates quickly, and so we lose the ability to control, to compare those pairs with a relatively clean control group. And also, we believe that to make this point that the propagation matters, we only need to show that the second degree propagation exists. So what would we expect from this specification? So first, we would definitely expect the beta 1 coefficient to be negative, right? Based on all of the things that I told you about conflict. So in general, the treatment here is relatively complex, right? So we are not going to disentangle different parts of it. The treatment here is, it could be violence, it could be destruction to infrastructure, it could be immigration, it could be transportation bottlenecks, or it could be just, you're not able even to cross the border because there is like a front line. So in general, the treatment is very complex. We're not going to unpack it, but from what I just told you about this treatment, the beta 1 coefficient should be negative, because otherwise it makes no sense. So then the beta 2 coefficient could be positive, could be negative. It depends on this substitution complementarity patterns in the economy. So why would it ever be positive? So you can imagine a firm that is buying the same product from two other firms. One of them is located in the contact area, the other one is not. And so after the start of contact, conditional that the demand of that firm for that product stays the same, you can imagine that that firm starts buying more from a firm in non-contact area. In that particular case, the beta 2 coefficient would be positive. But we're going to see which kind of side dominates. So the defined assumption is relatively standard. So absent the conflict, you have this parallel trends that hold. So in this table, we present the estimation results. So we have three measures of trade intensity between firms. So the first one is an indicator. It's equal to 1 if a firm sends something to another firm in a given month. And the second variable is the log of the number of shipments from a firm to another firm in a given month. And then the third measure is the logarithm of the total weight that the firm shipped to another firm in a given month. Of course, here there are ones inside, so zeros are zeros. So then, as you can see from this estimation results, the beta 1 coefficient is large and negative across the board. So that's perhaps not surprising, but more surprisingly, the beta 2 coefficients are also negative and significant. So they're about 4 times smaller. And in a simple aggregation exercise in which we take these coefficients very, very seriously, and we aggregate these effects up by the number of the first and second degree connections in the economy, we find that a naive regression that does not take into account the spillover, so if you take one of these 3 regressions in the first 3 columns, they will underestimate the total impact of conflict on trade by about 67%. So why is this number so large? It's just because there are many more second degree connections than the first degree connections in the economy with the conflict areas. And we argue that this effect is, this result is crucial for the conflict literature. So it may be kind of a little bit more obvious to people who know kind of the production networks literature. But if you're coming from the conflict literature, this result is very important because it means that the traditional estimates that compare within the same country violent and non-violent areas to get an idea about the economic consequences of conflict, they actually miss a lot of action in the rest of the country. And that's a very important point that we want to make here. So then here we present basically the same estimates, but in a dynamic form. So what we do here is that we, instead of using the post-conflict indicator in the specification that I mentioned, we use the quarterly fixed effects and interact them with the first degree indicator and the second degree indicator connections with the conflict areas. So on the left-hand side, you can see the dynamic estimates for the first degree effect of conflict on trade, and on the right-hand side, you see the second degree effects in the dynamic form. So then the conflict was very unexpected. And so you can see sharp declines right in the immediate, like right after the annexation of Crimea, and especially after the annexation, after the escalation of Donbass. Right? And then you can see that in terms of the second degree effects, they evolve rather slowly, suggesting that either there's slow propagation of the shocks on the demand side, or maybe on the supply side because of storage, for instance. So now let me talk about the second part of the paper. So the idea here is that the conflict shock may not only propagate through the production network, but also if the shock is large enough and if it's persistent enough, which is the case here, you may also see that the shock, like in our case, actually 3 large territories broke away from Ukraine, right? So it changes the production network structure itself, and this may have implications for individual firm performance. So that's the argument. So specifically in this context, we explore whether even conditional on the ripple effect that we have just estimated, whether the firms may gain or lose depending on the changes in the network position that happen for this exogenous reason that they have no control. So let me give you an example of what we mean exactly. So imagine you have a production network that looks like this. So in this production network, firms D and C have the same centrality, independent of the measure of centrality, right? But imagine now that firms B and G are in Donbass and Crimea respectively, and they become disconnected from the rest of the network for this because of the conflict for various reasons. So one of the implications of this, what you see here, is that in the rest of the country, firm D becomes relatively more central to firm C. So that and what we want to check is whether this has any implications for firm D's economic performance relative to firm C. So that's what we want to check. And here, we're gonna call this network post-conflict without adjustment. Why? Because there could be some adjustment as well, right? So there could be some adjustment. We think that it's endogenous and it could create some issues in estimation if we want to check basically whether this exogenous changes in centrality matters. So for that, we're just gonna calculate centrality here for each firm and calculate the centrality in this particular framework network for each firm in the past conflict without adjustment. And then about adjustment, we're gonna talk in the third part. So So we're going to talk about it, but not here. So what we show is that if we regress this log sales of a firm in a given year on firm and year fixed effects, and the interaction between the year fixed effects and this change in centrality that comes for this exogenous removal of firms that were located in the contact area from the network, then we see that firms that receive this exogenous boost to their centrality, they also in the short and the medium run receive a relative boost to their sales. So here we take the eigenvector centrality, but our results actually do not depend on other measures of centrality. Of course, different measures of centrality have different interpretations, but here, because the results are basically identical, we're just showing one measure. So again, you don't see any evidence of pretrans that suggests that, a difference in different strategies seems to be reasonable here. We also show that.
Yes. We have 5 minutes.
5 minutes, okay. So we also see that there is a bump in profits as well for this firms that became more central for the exogenous reasons, and we also see a temporary bump in markups as well, which we're not showing here, but which suggests that maybe these firms find themselves having like relatively more market power, and they increase prices and get a higher share of the market because of the kind of losing the competition. Right. So far we have documented this propagation effects and this network structure change effect that we think is novel to the literature. So then now we're gonna try to separate between the network destruction and network adjustment. So what we do here is that we build a general equilibrium model with CES production function and preferences. So we are very much building it on the works by Daron and co-authors, and on the work by Makarin and co-authors, and especially in this paper, they can go down from the sector level to the firm level analysis. So that's why that paper is especially important for us. So here we have n firms producing differentiated products, and then each product can then either be used in consumption and production of other goods. So relatively standard. So I do not want to spend time that I do not have on describing the model, but what I'm going to show you is that from this model you can get this firm level Leontief equation. So it's a standard Leontief equation, but instead of being at the sector level, now it's at the firm level. And here we have the production network matrix, the vector of total revenues, which is R, and then this alpha parameter, and then the demand vector outside of the revenue network. So that could be, in the model, it's the consumption, but of course, it could also, in our political context, it could be something outside of the railway network as well. So then in the what we do with this equation is that we can plug in the actual data for the revenues of the firms and for their connections and how much they're buying from each other. So this production network matrix is a square matrix with like elements varying from 0 to 1 that show how much a given firm buys from another firm in relation to all of its other inputs. And what we can do is that okay, we're going to define this production network without adjustment. You have already seen it. It's a network before the conflict, but now we removed firms that were located in the conflict areas and keep everything else the same. And we're going to estimate the distribution of firm revenues under 3 counterfactual scenarios. So the first counterfactual scenario is, we call it network destruction. It means that we keep the outside vector the same, outside demand vector the same, but we remove firms from the network and see what happens to the revenues. Then after that, we allow firms to adjust and find new firms and connections. We're not modeling how they're, like, what's the optimal kind of way to adjust their connections, but we actually take the actual connections that they found in 2014. So how did they readjust the network in reality? And then again, we keep the 2014 outside demand vector. And then in the third counterfactual, we just vary this outside demand vector just to see kind of whether it's important or not. And then these are the results. And then I just conclude very quickly. So here, how you read this table is this is the median of the revenue distribution that we obtain under some counterfactuals. So in the first column here is just the actual distribution of firm revenues in 2014. And this is the median firm revenue in 2014. It's about 2.3 million in US dollars in 2010. So then the network destruction counterfactual, actually removing firms from the network, decreases the median firm revenue by about 47% to about 1.2 million. And then the network adjustment compensates for about 80% of the decline. So in general, the median firm revenue drops from the baseline by about 10%, but still it's an improvement relative to what you saw before. And then the outside demand is responsible for about the 17% decline relative to the baseline. So, and the total change is just the sum, rough sum of the third and the fourth columns. So, okay, I don't want to spend too much time on it, but we also do some additional analysis. And to conclude, because I'm probably out of time, we use the data on firm-to-firm trade within Ukraine to show this additional consequences of conflict for firms in non-conflict areas. So first, we document these propagation facts. They are large. You should not ignore them. Second, we document this firm that suddenly gain their centrality because of this change in production network structure. They lose less in terms of sales and profits later on. And then we document this network adjustment channel that we are able to separate it from the network destruction channel. We think that it's important for economic recovery. So we hope that these results are especially, we believe that these results are especially important for the conflict issue, but we also hope that it informs the literature in production networks, just because we provide this rare evidence of how the economy readjusts after a pretty severe shock, pretty massive shock to the economy. Yeah, thank you very much.
Thank you very much. There is some questions and I'm sorry, Paulo, that I just let him go a little bit, and I'll go first and then open to the room. So I was just interested in a little bit more in understanding the counterfactual exercise. Like the equations you use seem very Cobb-Douglasy, but you seem to be working in a CES setup. So I'm trying to understand the mapping of data to the objects and how, meaning how exactly is that counterfactual being produced? So that's kind of question number one. Question number two is more, it would be interesting to get a little bit more detail on understanding this change in centrality, just to belabor the point that you're already making. But so we know, for example, that there are gravity type relations intra-country, right? So activity and new links should be formed close by, but not too close because of the war at the border, but also not too far away. So it should be there should be some spatial signal in there. And the other is, we know that there's a lot of heterogeneity at the firm level. So kind of one of the surprising results is kind of that you seem to want to push is that the network is actually quite flexible, and the rewiring of it dampens the impact effect quite considerably. At the same time, we have lots of estimates of kind of near Leontief type things where relationships are sticky and very hard to substitute away from. So I wonder if you can kind of observe heterogeneity that makes sense, right? Just to learn from the subject. So if I saw an A4 paper supplier, that should be easily substitutable, even by imports, which is something we didn't talk about, the external trade. But if I see kind of relation-specific goods, say by Rauch's measure or something like that being traded, do I see more difficult adjustment in the network?
Yeah. All right. So actually, yeah, let me start from the end. So so thank you very much, Vasily. So this is a great question. So actually, in our data, we also observe railway shipments with firms abroad, and we are not actually in this, like in the new version of the paper, we're not discarding them. So before we were discarding them only to look at domestic transactions. Actually, in the newer version, we actually don't do it. So now we actually have the potential substitution even with foreign companies, maybe not in the third part, but kind of in the first part for sure. So then regarding your first question about the Cobb-Douglas thing, so we are doing a CES here, and at some point, like first we started with the Cobb-Douglas, but then like some very smart people told us that actually this network destruction counterfactual that we want to pursue is sort of, that doesn't make much sense in the Cobb-Douglas framework, because if you remove an important input from your kind of like if it becomes unavailable to you because of the conflict, it just potentially shuts down your production. So we want to avoid that, and because of it, we switch to the CES framework. But in the end of the day, this Lorentz equation pops out nicely even then. So so then so in terms of heterogeneity for the so we do a lot of heterogeneity analysis, for instance, like in the first part of the paper. In the third part, actually, we don't do much in terms of roots. So we do split our results by the quantiles. So for instance, here we do median, but we can do it for quantiles. We can look at the dynamics, but we actually don't do different counterfactuals for different products. So maybe that's something that we should potentially explore more. So, and then. Yeah, and then I'm sure, I think I might have missed one of your, I think maybe
Don't worry, we could certainly talk offline and we can follow it up, but I guess we should open the room, and Paula had a few questions. They were borderline between clarification or not, but I just let you run with it. So Paula, do you want to come in now?
Oh yeah, so I had one question was about the specification where you estimate the indirect and direct effects. So this, so here, this partner conflict, captures whether firm I or J traded with someone in Donbass, and then YIJ is the trade flow between firms I and J, right?
Yeah,
so
exactly.
One thing that I was thinking about is that suppose that both firms trade with someone in the Donbass area, I guess partner conflict would be one, right? That's a dummy. And then, the effect of that could be the direct effect on the firms, because this firm is trading with the Donbass area, right? So you could be capturing the direct effect. So is this a concern for you, and can you make sure that you don't get this confounding effect?
So can you, my apologies, can you repeat it again? So what you mean is that both firms could trade with the contact area,
Exactly.
and that could be a direct effect?
Exactly, yeah. So suppose both firms trade, so conflict IJ is a dummy, right? That takes the value of 1. So suppose that, so what happens here if, I'm just worried because firms that are close to the area, probably both, this happens a lot with firms that are close. Now, maybe there's a lot of incidences where both firms trade. So I was wondering if you could write a specification, where you take into account, when you look at this trade flow, you take into account whether just one of them, the other, or both, right? You could have 3 different dummies. Right. And then in that way, you could separate these effects, because
yeah, we can do that potentially. Yeah. So yeah, right now we only do one, we don't do both. So yeah, there could be like some intensity.
This could capture the direct effect. Otherwise, if you have a lot of incidents in which both of the firms trade with that area.
Yeah. So if by direct effects you mean that some firms are just located super close to the conflict area, so that we actually we have some robustness check where we actually interact also the past conflict indicator with the distance of both firms, one firm and another firm, from the conflict. So we calculate those distances. So if the distance to the conflict area is a concern, then that can be addressed. And so I get your point that this partner conflict we treat it as a dummy, but could potentially take 2 values. So it could be one partner had been trading, or 2 partners. So actually we haven't explored it. Yeah, we can check very quickly just to see whether it has like some heterogeneity by that.
I mean, it's not heterogeneity, it's a concern that when both partners are trading, then this could capture the direct effect.
I see. So I see. So you're saying that both of them are trading. So this first effect sort of spills over onto the second one. I see. I see.
Yeah.
I see what you mean. I see what you mean.
And then a second question I had was about international trade, because you had, you know, I don't know what happened at the time, but I imagine that, you know, when Russia invaded the Donbass, there was a general disruption of trade between Ukraine and Russia. So I guess for firms that were close to the Russian border, they might also have lost centrality relative to international trade. So I wonder whether you are, you know, taking that into account, because that could also generate, you know, biases in the estimates.
Yeah, no, this is a great point. So actually, in our companion paper that we have, that is more about the interethnic implications between in trade between Ukraine firms and Russia. In that paper, we actually talk about the decline in trade between the two countries. So of course, it happened, but it actually happened. It actually was not abrupt. So trade between Russia and Ukraine continued to flow at more or less like zero tariffs, because they were part of the CAS free trade agreement, and Ukraine only exited the free trade agreement only like in January 2016. So actually, you know, the disruption between the two countries was not as large, which is like a caveat here. So I guess I should mention it somewhere in the paper, actually. Not that you bring it up.
So thank you very much. Are there further questions? I am trying to see the gallery and see if there is anyone with their hands up. If so, I will just follow up with one other question, which is, you know, it's just again another mechanism through which this may, you are kind of putting a lot of emphasis on the reallocation of firm-to-firm demand and supply, I guess. But there, you also mentioned in the talk that there is substantial displacement of people. So there will be areas of the country where there will be, you know, just increases in final demand in final local market size, if you want. Meaning, if I want to think about whether this constitutes a source of growth for these firms. So I guess the question is, are firms that gain centrality also firms where there's an increase in population, and that's really not going through these linkages, but just final demand is operating in a relatively standard way?
So that's definitely a thing that we would like to think about more. As I mentioned, 2 million people were displaced. 1/3 went to Russia, 2/3 went to the rest of Ukraine. So there's a huge shock in terms of labor. Unfortunately, we are a little bit constrained data-wise. The only data on migration, ideally, we would want to have like data on this refugees resettled in different cities and the number of refugees that was resettled for each city. So unfortunately, we have this data only at the region level, at the province level. We can still use them potentially, but then, yeah, we could still use them in principle. We haven't done it yet. But one thing that we think could be an argument that this should not be a big issue is that, like, if we think about where refugees would probably go, they would probably go. We don't know that that's true. It's just our hypothesis. We think that they would go probably to areas that are more economically connected to the Donbass region, and those areas would probably have more firms that are more connected to the conflict area, and so the firms that are more connected to the conflict area are those that probably for which the centrality decreased the most and which were more affected by the first degree effects. So if anything, we would probably think that the relocation of people would bias our results in the opposite direction. But that's, of course, more like a verbal argument. Yeah, data-wise, as I said, we're a little bit constrained. So. But this is a very good point. It's a very important part of the content.
Thank you. Any questions in the room? If not, I would propose, subject to the ruling of the bosses, that we move to the next paper. I think we're 1 minute. So I think the presenter will be Hiroshi Toma on cultural proximity and production networks. Hiroshi, it's your.
Can you see my screen?
Yeah.
Yep.
Thank you to Vasco and Paula again for the
Sorry.
questions. Thank you.
Thank you, Alexey.
All right. So I'm going to start. So thank you for having us. And thank you for coming to our presentation. So today I will be presenting this paper titled Cultural Proximity and Production Networks, which I've been working on alongside Gaurav Khanna and Brian Cevallos, who, by the way, will be going to the job market this following season. Also, please keep in mind that both of my co-authors are present today in the meeting. So if you have any questions, please write them down in the chat and my co-authors will be very happy to answer your questions. Okay, so having said that, we can move on to the introduction. Okay, so we will begin from the premise that there are frictions in trade. So there may be contracting frictions, there may be informational frictions. Now, economic literature shows that in developing countries, firms usually rely on informal institutions to solve these frictions to trade. In particular, in our paper, we will focus on the informal institution of cultural proximity. So we understand cultural proximity as people sharing the same codes, sharing the same language, sharing the same religion, sharing the same ethnicity. Now, to illustrate how cultural proximity can affect trade, I will give you an example. Let's say that there is a supplier that sells rubber to a shoemaker in India. Okay, so we have two firms in India, and one wants to sell rubber to the other. Now, the supplier, let's say that the supplier doesn't know the shoemaker, and the supplier doesn't know if the shoemaker will pay. Now, let's say that while negotiating, both the supplier and shoemaker realized that they were raised in the same part of India, let's say northern India. Now, this fact will give the supplier some information on the set of values, on the set of beliefs of the shoemaker. Now, based on this information, the supplier will decide that he trusts the shoemaker and they will engage in trade, right? So this is an example of how cultural proximity can define trade, can affect trade. Okay, and this takes us to our research question, and that is where cultural proximity can help solve the trade frictions at the firm-to-firm level. And for this, to answer this question, we will use some new data to provide some new empirical facts, and then in order to see what are the aggregate effects of cultural proximity, we will use a quantitative model. Okay, so in a nutshell, what we do in this paper, in first place, we will present two new datasets. The first one is a firm-to-firm trade dataset for a large state in India, and the second dataset has information on cultural endowments for the CEOs of the firms. Now, I will define this term cultural endowments in a while. But the important thing about cultural endowments is that once we have this information, we can construct a measure of cultural proximity between firms, between pairs of buyers and sellers. Now, then with this data, we will find some empirical facts. The first one will be that the higher the cultural proximity in between a pair of buyer and seller, the larger the trade in the intensive margin, and also the larger will be the trade in the extensive margin. Also, the higher the cultural proximity, the lower the prices that are registered in the transactions in between these pairs of sellers and buyers. With these empirical facts, then we will move on to a theoretical model where cultural proximity will affect the trade cost and the matching cost. And then with this model, we can perform some counterfactual exercises. Okay, regarding the literature review, our paper relates to two large groups of papers. The first group talks about how cultural proximity can affect different economic outcomes, not only trade, but also other outcomes. And then we'll relate to a second large group of papers, which talk about production networks, right? So talk about trade at the firm-to-firm level. So our contribution, the contribution of this paper that I'm presenting today, is to bridge the gap in between these two groups of literature, of economic literature, by providing evidence and theory on how cultural proximity affects trade at the firm-to-firm level. Okay, and now we will move on to the empirical facts. So in first place, we must present our datasets because our datasets are new. So the first new dataset we have is this firm-to-firm trade dataset. So we have daily establishment level transactions for a large Indian state for the year 2019. More specifically, we have information about the values, about the quantities, about the unit prices. We have the location of the buyer, we have the location of the seller. We also have the classification of the good that is being traded. And now this figure that we have right here, this illustrates what kind of information we have in our data, right? So we will have all this information for all those transactions in which at least one part of the transaction, either the seller or the buyer, belongs to the home state. Okay, so this is the information we have in our data. Now, before moving on to present our second new data set, we have to talk about the background, and that is the background of cultural groups in India. Okay, so in our data set, we have 452 different cultural groups. So in a first level of aggregation, the cultural groups depend on religion. Okay, so you can belong to the Hindu religion, or you can belong to other non-Hindu religions. If you belong to other non-Hindu religions, right, like the Christians or the Muslims, we will say that each religious group conforms its own cultural group. Okay, but now, if you are of Hindu religion, then you will be subject to the caste system, right, which is a hierarchical social system in which we have 4 different large groups called varnas, right? And what's particular about these varnas is that each group sits atop of the other, right? So we have one group on top of the other on the hierarchical or social order. Now, each of these varnas is subdivided in dozens of smaller groups called jatis. And following the economic literature, we will say that the jatis are the proper unit for economic analysis because the jatis are born out of economic reasons. They are determined by occupation, they are determined by tribe, by language. So which jati you belong to will determine who you work for, who you hire, what you produce, what you buy. Okay, so we will treat each religious group as its own cultural group in case you don't belong to a Hindu religion, or if you belong to the Hindu religion, we will say that each jati is a cultural group. Okay, so now with this, we can move on to present the second data set. Okay, and that is the, in this data set, we have information about the names of the CEOs and the cultural endowments. So in first place, the names of the CEOs, we get this information from 2 different sources. For the in-state firms, we get information from the state tax authority. And then for the out-of-state firms, we obtain this information by web scraping data from IndiaMart, which is the largest business-to-business online platform in India. Now, regarding the cultural groups, what we have is a probabilistic mapping of the surnames of the CEOs to the different cultural groups we have in our dataset. And for this, we will be using the data and the methodology of this paper by Bagabatula and co-authors, where they web scrape profiles from matrimonial websites in which people list their surname, list their religion, and also list their jati or their caste. Right? So with this information, we can construct this measure that we define or that we call cultural endowments. So the cultural endowments will be the probability, or a cultural endowment will be a probability distribution of belonging to the different cultural groups we have in our dataset. So in the end, each CEO in our dataset will get assigned a vector row of probabilities of belonging to each cultural group based on the surname that he or she has. Right. So for example, let's say that I am a CEO of a firm, okay, and I have a certain surname. So I will get assigned a vector row of probabilities, and I will have a 10% chance of belonging to cultural group 1, a 20% chance of belonging to cultural group 2, and so on. Now, if you are a different CEO of a different firm with a different surname, then you will get assigned a different vector row of probabilities of belonging to the cultural groups. Okay, so each CEO will have its own cultural endowment. Okay, so after marrying everything, we get to our final dataset. So this is a firm-to-firm trade dataset with firm-level cultural endowments for the year 2019 for these large Indian states. So we have information for around 22,000 unique firms. We have around 154,000 transactions, which are equivalent to approximately $5 billion. Okay, now given the data that we have, how to measure cultural proximity? So in order to do this, in order to measure cultural proximity, we introduce the Bhattacharya coefficient. Okay, so now in order to construct the Bhattacharya coefficient, we take rho XS, which is the probability of the seller of belonging to cultural group X. We take rho XB, which is the probability of the buyer of belonging to cultural group X. we take the product, we take the square root, and then we sum over all the cultural groups, right? And then we get our Bhattacharya coefficient. Now, the higher this Bhattacharya coefficient, the closer the buyer will be to the seller in cultural terms. Okay. Now, on the other hand, the lower the Bhattacharya coefficient, the lower this measure of cultural proximity, then the farther away the buyer will be to the seller in cultural terms. Okay, and then we can construct this Bhattacharya coefficient for each pair of buyers and sellers that we have in our data. Okay, so after introducing this measure of cultural proximity, we can move on to present empirical facts. So empirical fact number 1 says that cultural proximity fosters trade. So here we have the Bhattacharya coefficient, right? So the higher the Bhattacharya coefficient, the closer the buyer will be to the seller in cultural terms, right? And then the larger the sales and also the larger the transactions, right? And here in these results, we are controlling for seller fixed effects, buyer fixed effects, and also the listings. Okay, so this is our first fact. The empirical fact number 2 says that the higher the Bhattacharya coefficient, the closer the buyer will be to the seller in cultural terms, then the lower the unit prices that are registered in the transactions that happen in between these pair of firms. Okay, so we become culturally close, or we are culturally closer, then the lower the prices. And finally, the empirical fact number 3 relates to the extensive margin. And this fact number 3 says that cultural proximity increases the likelihood to trade. So in order to show this, we run this regression, which is a standard gravity regression, right? Where we introduce the Bhattacharya coefficient, our measure of cultural proximity, and then our dependent variable will be this dummy variable, which will be 0 whenever there is no trade in between firms, in between the seller nu and the buyer omega, or will be equal to 1 whenever there is trade in between the seller nu and the buyer omega, right? So here for this regression, for our sample, we consider all the feasible combinations of buyers and sellers that we have in our dataset, and we find this positive coefficient that says that the higher the cultural proximity, the more likely it is that seller nu will trade with buyer omega. Okay, so I will move on to the discussion of the results. So just as a summary of what we found with the data, we have that the higher the cultural proximity, the larger the trade in both the intensive margin and the extensive margin, and also the larger the cultural proximity, the lower the prices. Now the question is how to rationalize these results. So we started from the premise that there are contracting frictions, that there are informational frictions in developing countries, right? Which are places in which markets may be incomplete or institutions may be lacking. So this should relate to high trade costs and also to high matching costs. And now we propose cultural proximity as a solution when markets work imperfectly. Right? We propose cultural proximity as a solution to the contracting frictions, as a solution to informational frictions, in such a way that there will be more trade and there will be lower prices, right? Which is what we find in the data. Okay, now armed with these empirical facts, we now move on to present our theoretical model with which we can later quantify which are the reality effects of cultural proximity. So this is a standard firm-to-firm trade model based on this paper by Bernard and co-authors, right? We have a closed economy, we have a continuum of firms, and very importantly, or most importantly, there is this runabout production economy. So this means that firms are trading in between themselves, right? And our modification will be that we will introduce this definition of cultural endowments, right? So each firm omega will receive a vector rho, which will be its cultural endowment, right? So each firm will have different probabilities of belonging to the different cultural groups, right? And more importantly, with these cultural endowments, we then can construct a measure of cultural proximity, the Bhattacharya coefficient, in the same exact way we did in the data, right? So also in our model, we will have this measure of cultural proximity, the Bhattacharya coefficient. Now, from this model, we can derive in first place a gravity equation, right? So here we have a gravity equation, and are the sales going from seller nu to buyer omega? and D are the trade costs. Okay, and now we will introduce cultural proximity as a wedge in the definition of the trade cost, which we have right here below. Okay, and the cultural proximity will be introduced in the trade cost in such a way that the higher the cultural proximity, the lower the trade cost, and then the higher the sales. Okay, so this relates to the intensive margin. Now, for the extensive margin, we first present what we call the link function, and the link function is basically the probability of matching, the probability that a seller new will sell to a buyer omega. And what this expression says is that a seller new will sell to a buyer omega whenever the profits of doing so are higher than a matching cost F and a random noise epsilon. Okay. Now, the way that we introduce cultural proximity in the extensive margin is also as a wedge. In this case, we introduce the social proximity into the definition of the matching cost, and we introduce this measure in such a way that the higher the social proximity, right, the closer a buyer will be to a seller in cultural terms, the lower the matching cost, and then the more it is likely that the seller new will sell to buyer omega. And finally, we can also derive an expression for the prices, right? So from the profit maximization of the seller, or the sellers, right, we find that the unit price of the good that seller new is selling to buyer omega is equal to a markup mu, a marginal cost C, and also the trade cost B, right? And as before, right, we define the trade cost to depend on the measure of cultural proximity in such a way that the higher the cultural proximity, the lower the trade cost, and then the lower the unit price. Okay, so this is picking up the empirical fact that we had before. Now, how to parameterize our model? So in first place, we have a group of parameters that is estimated, right? So for the cultural group probability distribution, right, these probabilities, these cultural endowments that firms have, right, we draw these probabilities from a Dirichlet distribution, and the parameters of this Dirichlet distribution are estimated by maximum likelihood directly from the data. Okay, then for the trade cost semi-elasticities, right, remember that this D is a trade cost, we estimate beta 1 and beta 2 directly from the data using the intensive margin regressions we have in our paper. Okay, so these come directly from the data. And finally, the matching cost semi-elasticity, this gamma that enters the matching cost F, we also estimate this directly from the data using the extensive margin regressions that we also have in the paper. Okay, then second group of parameters, we calibrate them, right? And we calibrate them either from our datasets or from our papers. And the remaining parameters are the parameters that are related to the productivity distribution and to the link function noise distribution, right? So in order to calibrate these parameters, we use the simulated method of moments, right? So we target some moments, and then we find the parameters, the values of the parameters. Okay, with this baseline calibration, we can now move on to present the counterfactuals. So for the counterfactuals, we'll be analyzing all of these measures. We will analyze welfare, we will analyze the sales weighted average productivity. We will see what happens with the sales, with the price index, and then we will introduce these two measures that these two measures of connectivity, right? The average number of buyers firms have in our model, and also the average number of sellers firms have in our model. Okay, and now for our counterfactuals, in the first counterfactual exercise, we will say that we all go to sleep today, and then tomorrow, when we will all wake up, we all belong to a different cultural group. So what happens is that we all become the farthest away in cultural terms. In counterfactual number 2, we will say that every firm belongs to the same cultural group. So this means that we all become the closest in cultural terms. And here are the results, right? So all of these are changes relative to the baseline. And in our first counterfactual, where each firm belongs to a different cultural group. So this means that every firm becomes the farthest away in cultural terms. What happens is that every firm is paying the highest matching cost, and every firm is paying the highest trade cost. So there will be lower welfare, there will be lower sales, there will be higher prices. Firms on average will have less buyers and less sellers. And the only result that may seem a little off is this one, in which the average productivity goes up. But I will explain this result in the following slide. Okay. Now, for the second counterfactual, in which all the firms belong to the same cultural group, we have that all the firms pay the minimum trade cost and all the firms pay the minimum matching cost. So this will generate an increase in welfare, will generate an increase in total sales, will generate or will cause prices to be lower, and firms on average will have more buyers and more sellers. Now, once again, the only result that may seem a little off is this one, in which the average productivity goes down. But now, in this slide, I will explain the results behind the average productivity. Okay, so in the first case, when we all become culturally the farthest away, we have that everybody is paying a higher matching cost and paying a higher trade cost. And here we can see that in terms of sales, right, everybody loses, all the firms lose. But the ones that lose the most are the least productive firms, right? So what is happening here is that the weight of the most productive firms is increasing relative to the weight of the least productive firms. And then the end result is that the average productivity, the sales weighted average productivity, will go up. In the second case, we have that in terms of sales, when we all become culturally closest, in terms of sales, we all win, right? All the firms win. But the ones that win the most are the least productive firms. So the weights of the least productive firms will increase with respect to the weights, or relative to the weights of the most productive firms. And because now the least productive firms have a larger weight in average productivity, then the average productivity goes down. Okay. And now the conclusions, which are very brief. And those are that cultural proximity can help solve frictions in firm-to-firm trade. And for this, we use some new datasets and quantitative model to show our results. And what we find is that a higher cultural proximity is related to more sales, more matches, and lower prices. All right. And that's all that we have to say for today. Okay, thank you very much.
All right, thanks a lot, Hiroshi. And there was a lot of action on the chat. So I was trying to go over the paper quickly, but just to.
Sorry, Vasily, your microphone's very
Yes.
muffled or something.
Oh, that's weird because I haven't done anything. You see this always goes wrong. Can you hear me now?
It's still quite muffled.
There seems to be some feedback.
Vasco, if you want, I can ask my questions while you fix it.
Go for it.
Yeah? Okay. I have a couple of questions. I think I really like the measure of cultural proximity that you developed. I think is very, it's super interesting. But something I was wondering, to the extent that the JATI, entails, three things that we know. One is common language, the other is common religion, and the other is common occupation, but let's focus on the first two. And, both common language and common religion have been introduced in gravity equations, in cross-country gravity equations, and that have been shown to have a strong effect on trade flows, both in the intensive and the extensive margin. So then I think, again, I really like what you're doing, and I think the paper is very interesting, but you need to tell us To what extent what you do is just, a firm level version of something that has been already established with cross-country, trade flows, right? To the extent that Jati is a way of saying, okay, it's a bundle between common religion, common language, and common occupation. So that's my first comment. And a second comment, so let me just tell you both, and then a second comment regards the estimation, right? You are estimating the effect of this variable of cultural distance on two types of parameters on the cost function. One, on the variable trade costs that are going to determine the intensive margin, and then on the fixed trade costs that are going to determine the extensive margin. And the problem you have here is an identification problem, because you have the same variable for both, but the decision of whether or not to trade with somebody depends on two things: the fixed cost and the variable cost, right? So if the same variable is affecting both, you cannot separately identify with just one variable the fixed and the variable, elasticity, the elasticity of trade cost in the fixed and variable trade cost. So one paper that does that is, the paper by Hellman, Melitz, and Rubinstein. I don't know if you know this, it's a 2008 2J paper. And basically what they do is they argue that they have an excluded variable that only affects the fixed cost, which is religion in their case. They say, so why don't you take a look at that and see whether you can separately identify those using some strategy like what they do there.
Okay, that's great. Thank you for your comments. Yeah, definitely we will check into this. I don't know if my co-authors have something to say.
Yeah, Paolo, I think these are great suggestions, actually. Thanks for bringing that. I guess the nice thing is that you're suggesting that the culture is actually multidimensional. And I mean, trying to put both your comments together, actually, culture is actually multidimensional. And we can not only try to disaggregate the different dimensions. So for instance, we can do linguistic distance. We have measures of linguistic distance. We can see how important that is relative to, say, religion, something. And then it also gives you different sorts of variation to identify parameters, two different parameters, right? So you could say, okay, instead of using the same measure to estimate both the fixed cost of matching and the variable trade cost, you could have almost two different versions. So yeah, we'll check out that paper, but I think it's a great point. I'm trying to say that there's a multidimensional type of thing here that you can try to disaggregate, which we definitely should. But yeah, and you're right about the fact, there's some other papers on looking at like the international trade aspect of it, where I think the idea there is like, when you're cross-border trade, there are certain barriers you need to overcome, which you may not have expected to be as prevalent within a country, but it seems like in a context of low contract enforcement, it can be quite important here. But I think these are great points. Thanks.
All right, can you hear me now a little bit better or not really? Not at
Also,
all.
there may be some interference. Is there some other electronic?
Vasco, maybe you can write your comments in the chat and we can read them. That's an option also, okay. While maybe Kevin can ask his questions while you write.
Yeah, I had a similar question to Paula, so let me just defer and let Catherine ask her question first, and then if we still have time, I'll fill in some details of what I was wondering about.
Okay, great.
Sure, thanks. I just had a question about the why you go directly to subcaste and splitting all of the other religions into a single bin. Like, why not start from caste and religion? Because like within Muslims, there's going to be a lot of sectarian divisions. But my understanding of the way that you're identifying this from last names, and my understanding is that it's very easy to tell the Varnas from the last name, but there's a lot more overlap with the Jatis. So I'm wondering why the decision was made to go that way rather than start from something larger. And I guess it's related to the other question about overlapping.
So yeah, in the first place, yeah, while we have the jatis for the people of Hindu religion, we don't have like this kind of subgroups for the other religions. So that's why we are considering these religions as their own very large group, and that's it. So this is for your first part of the question. And then in the second part, for the second question, yes, we do know that there's a lot of overlapping regarding the last names, the surnames, but that's why we have a probabilistic measure. Sorry, where is it? Well, yeah, we have a probabilistic measure. So based on the data from these matrimonial websites, if you have a certain surname, there will be 50 people that say, okay, so I'm from Jati A, and there will be 50 other people that say, I'm from Jati B. And then we get some probabilities on that, right? So our probabilistic measure should somehow control for the fact that there may be people lying, there may be some kind of misclassification, there may be surnames that are written in a certain name in a certain way, surnames that overlap a lot across the jatis, right? So that's why we get our probabilistic measure. And in a sense, this is better than, oh, sorry, go on.
No, Casimir, I think this is a great point. It's, yeah, so the other religions are small enough in this context that there's not a lot of, so there's not a lot of divisions within them that we can leverage in terms of variation. So like, the Christians and Muslims are small groups that are almost as big as only certain jatis in this context. So in terms of size, we can't go into, but we could use the Varna variation. So we have, I don't know, Hiroshi, if you have the table in an appendix slide, you could do it at the aggregated level. The thing about Varna, they're hierarchical. So it's not just about proximity, but actually about also discrimination at some level, right? So what we do is we actually, I don't know, Hiroshi, if you have that table, but essentially what we see is even within the hierarchical group, there is this cultural proximity matters a lot. So even within a Varna, right, you can see that the cultural proximity across jatis is really quite important. So this is maybe a little the notation we haven't explained here, but these are indicators of high Varna versus low Varna, and which is the interaction term in the second row, and then low Varna versus high Varna, so which is the buyer is low Varna versus high Varna. So those are cross Varna traits, right? Those are not differentially impacted, as opposed to even within the same. So the first row is just within the same Varna, but across jatis. So even within a major caste group, right, across jatis, that cultural proximity is very important, right? Because in India, it's just so salient. People just see my last name and they say, okay, you must be this jati. And it's just so salient that jati level itself is important enough here.
Yeah, no, thank you. That answers the question. I guess in terms of framing, I would have liked if we started from the top and then
right,
went into
and then build it
the heterogeneity, right? Because I think that's very interesting. Thank you.
Yeah,
okay, thank you.
Thanks.
Cool. So I'll abuse my role as organizer here for a second. So I really liked it. My